From this section, we will be working on our new project Expense Tracker Pro. So let's have a sneak peek at what we will be building. We'll start by setting up a project. Then we'll be integrating MongoDB and set up models and schemas. We'll then work on user registration and user login. Then we will be learning about authentication middleware, how we can use JSON web tokens for authentications. We'll also be learning about sending emails in Node.js, how we can create forget and reset password routes. And in between, we'll be learning so many things that will help us become a better backend developer. And then we'll be working on live deployment and testing our live API. I'm excited for this section and I hope you are too. So let's get started. Before we dive into the development process, let's have a look at the system that we are trying to build. This is an Expense Tracker Pro blueprint and it will help us understand what are the things that needs to be done for creating this app. Now, as you can see, we'll be having two routes initially, the user registration and user login. So we will start our development by creating a user registration route from which we will register the user and keep the user data in our database. And then we will be working on user login. After that, we will be creating a user dashboard, which will be a protected route. In this lesson, we will also be learning, or in this part of the project, we will also be learning how we can create a protected route and how we can authorize the user to be able to access the protected routes. And then we will have the transactions. We'll allow the user to enter the transactions, and transaction can be of two types, income and expenses type of transaction. So when user enters certain amount as an income, we will be adding that income to our user balance. And when user tries to enter the expenses, we'll be deducting it from the user balance. And then in the dashboard route, we'll be showing the user balance and most recent 5 transactions. Now, by having a glance at this blueprint, it seems like a very basic project and there's nothing much to learn while creating this project, right? But in reality, we'll be learning so much more stuff in this project. We'll be learning about the public route and protected route. We'll be learning how we can protect the route from unauthorized access, how we can authenticate the users for them to be able to access the protected route. We'll be learning about encrypting data in the database, about JWT authentication and how we can authenticate the user. We'll be learning about working with multiple models and schema and how we can create a link between them. And we'll be learning so much more throughout this project. So let's get started by setting up this project and starting our development in Expense Tracker Pro. So I'll see you at the next lesson. From this lesson, we'll be working on our new project Expense Tracker Pro. We'll be applying everything that we have learned till now, and then we will dive even more deeper into the backend development. So let's get started by creating a new directory. So I'm using Expense Tracker Pro as my directory name. Now let's open this in VS Code. Now once open, let's create our first file app.js. This will be our entry point, and then go into the new terminal and then npm install Express. We will be installing all the dependencies. Also, it is recommended that first we do npm init before installing the packages, but running it later is also fine. So in typing this enter will do the job, and then we will be getting our full package.json file. So next dependency that we will be installing is the nodemon. So npm install nodemon. Let's initialize the nodemon now. So in package.json, if there is an npm start, then it will run nodemon app.js. So let's save this. The next dependency that we will be installing is npm install express async -errors. And now we can start our coding. So navigate into app.js. First import the express const. Express is the require express. And before that, we need to require express async errors. And almost forgot, we need to install the Mongoose as well. So npm install Mongoose. So now let's create a server. So const app is the express app, and then app.listen will be listening to port 8000, and if connection is successful, we'll be consoling server started successfully. Right, let's save this and let's perform npm start. And sometime you might be getting this error. This e address in use is the error that is triggered when this port 8000, something is running on port 8000. So if this error occurs in your side, check if there are any instances of VS Code open in which the server is currently running on port 8000, and if they are running, then you can close that VS Code. Or if you have installed any other system that is using port 8000, then our server could not access the port 8000, so you might need to change the port. But for me, I'm currently using another VS Code for restarting the server, so let me close that. So after closing it, let me terminate this and npm start again. So now the server has started successfully. So we have set up all the dependencies that we might require, and if we require some more, we will be installing in the process of development. So now let's create our error handler as well, because eventually we need to do that. So new folder handlers, and then inside of it, new file error handler.js, and inside of it const error handler equals to an error function, and module.exports is the error handler, right? And this is const. Save this, and this will have an ss2 error request response and then next function, right? Now if there is an error, we will be sending a message of res.status 400.json status failed, and then error will be the error, right? And if nothing is there, we want it to move to the next section. So let's save this and import it in our app.js. So at the end of all routes, and after this we will be importing our file. So app.use, and then inside of it we will be writing error handler. Let's save this. And the next thing we might need is app.use express.json. And another file that we need is .env file that will be used to store the secret data of our Node.js app. So seems like everything is set up. So let's move to another lesson, and in that lesson we will be connecting to our MongoDB database. So I'll see you there. So now that we have set up our project, let's go ahead and connect to our MongoDB database. Now for this project, you don't need to go to a MongoDB Atlas and create a new account. We can use the same connection string but a different database. So bring up your connection string from env file of your MoviesDB and then paste it in our environment variable file. So the thing that you need to understand over here is you can use a same connection string but be able to create and use multiple databases. Now the connection string that you see over here, this connection string is for the MongoDB cluster. If you navigate into the MongoDB compass, this whole system is a MongoDB cluster and not the database. These are the database, right? A cluster can have multiple databases. So in order to create a new database and use that for this project, simply rename this MoviesDB with the new database. So I'll be using Expense Tracker Pro or Expense Tracker DB, and by doing this I'll be able to create a new database into our cluster and then use it for the development of the expense tracker. As simple as that. Only you need to do is you need to rename the database. So now that you know, you do not need to create MongoDB Atlas account for every project. So now that we have our connection string in our environment variable, let's go ahead and connect to our MongoDB database. But before that, for accessing the environment variables, we will be needing .env package. So let's install that. So npm install .env. After the installation, we will be importing. So require .env and then execute the config function. So now we will be able to access the environment variable. So let's connect to our MongoDB database. So after the app is declared express, we'll be connecting. So first let's import the Mongoose. So const Mongoose equals to require Mongoose, and then mongoose.connect. The first is the Mongo URI. So process.in or environment dot the key Mongo connection, and the second will be the configuration. We'll leave it as it is, and then if the connection is successful, we'll be displaying console.log Mongo connection successful. And then if there is an error, we'll be displaying Mongo connection failed. So now let's start our project and npm start. And there you can see server started successfully and the MongoDB connection was also successful. So let's navigate into the MongoDB compass and refresh this globally. So you can see that we do not have an expense tracker pro DB currently in our database because without the collection, it will not be displayed by the MongoDB compass. So now that we have connected to our MongoDB database, let's go ahead and create our first model. And the first model will be the users model that will hold the registration data of our users. So let's create a new folder. And the folder name will be the models. And inside of it, there will be a file called users.model.js. And inside of this model, we'll be writing our model development code. So let's first import Mongoose. So const Mongoose will require Mongoose, right? And then we'll be creating the model. So const users model equals to mongoose.model, and then inside of it the users and then the users schema. Let's create this user schema. So const user schema equals to new mongoose.schema .schema, and then inside of this there will be an object that will hold the schema data of the users. So for the user registration or for storing the users data, we will be needing the full name of an user. So full underscore name, and then this will be of type string, and this is a required parameter true, and if user does not provide it, we will be writing please provide full name, right? And the second object will be the email address, so email, and then this will be of type string, and then this will also be a required field, and if user doesn't enter it, email is required. Also let's rename this as well, so full name is required, or simply we can ask for name, and this will be name is required, right? Now if you want a certain variable or the certain field to be unique, then you can write this validation in the model itself. So for that, unique equals to true, and if the user tries to provide the same email address for the registration that is already registered, our Mongoose will throw an error, right? Now the other fields are name, email, and other field is password. So the password will be of type string, and then password will be the required field, and password is required, right? Now let's add one last important field, and the field will be the balance that will hold the actual balance of the user. So this will be of type number, right? And this is also required, balance is required, and then its default value will be the 0. So if the value is not provided in the balance, then the default value will be 0. So this is another rule for the schema. If you want the default value to appear even if the user does not provide it, then you can provide the default value. Now I think these fields will be enough for now, and if you need any other field, you can always come here and add the field. So let's save this, and now let's initialize it in app.js. So after the Mongoose connection, let me write a comment. So models initialization, and here I'll be requiring the models, and inside of it users.model, but I have not exported from here. So module.exports, and then the model name users model, right? Let's save this, and by doing this our model has been initialized And if you navigate into the MongoDB compass and refresh your page, you can see that there is a new database called expense tracker DB, and inside of it there is a collection called users. So now that we have user collections or user model, let's go ahead and create our user registration route. So I'll be seeing you at the next lesson. In this lesson, we'll be learning about modular code organization in Node.js, or I like to call it modular approach of Node.js. And this approach will help you when you are working with larger projects. Now, if we have a look at our previous project, Movies API, you can see that for every route, we have a controller, right? And we have created a folder named controllers, and we have kept all the controllers over here, which is a good approach in itself, because writing everything inside of app.js will make our code more complex and difficult to maintain, right? So instead of writing everything inside of app.js, we created different files, and different functions will handle different aspects of our API. Now generally this will be a good approach because it will make our code more maintainable and easier to read. But when we are working on a larger project, it might not be enough for making our code maintainable and easier to read, because inside of controllers there may be hundreds if not thousands of files, and it will be difficult for us to maintain our code base. So for removing or reducing those complexity, we will be learning about modular code organization or modular approach of Node.js. In modular approach, instead of writing everything inside of a controller, we'll be splitting the functionality of our entire project into different modules and work on different aspects of our functionalities in a different module. So let's see how it's done. Now, if you look into the blueprint of Expense Tracker Pro, I can see two different modules. The first module will be the user module, in which there will be everything from user login, registration, authentication to different other things. And then another module will be the transactions module, which will handle the transaction. So what we have done is we have splitted our entire project functionality into two different modules. The first one being the user part and the second one being the transaction part. So now instead of creating a controller over here, I'm going to create a new folder called modules, right? And inside of modules, I'll be creating two folders. The first one being users, and inside of module there will be another one called transactions. Make sure that this transaction is a child of modules and not of users. So inside of the modules there will be one transaction and one users. So this transaction module will handle everything related to the transaction, and this users module will handle everything related to the users. At first we will be working on this users module, and in the later part of this course we will be working on the transaction as well. But for now, let's work inside the users. So inside of users, let's create a new file, and the file name will be users.routes.js. Now in this users route, we will be handling, or we will be keeping all the routes instead of populating our route in app.js. What it does, it makes our app.js simple and easier to read, while we will be handling all the functionalities related to this user module or related to this API endpoint from user routes.js. We are making our code simpler and easier to read, right? And inside of this user folder, we will have another folder called controllers. And inside of the controllers, there will be all the logics of users related to users. So user login, user registration, everything will be inside of the controllers. So let's create a file inside of a controller called register.js. So let's get started by creating a user registration functionality inside of register.js, and then we will be linking it finally to app.js. So const register equals to an arrow function, and then module.exports equals to register, right? And inside of this we will have an SS of request and response, though we have not sent it, but it will have a request and response parameter once we import it in app.js. So request and response, and in response we will be sending res.status 200, and then the JSON. Inside of it will be the status and hello from register, right? Let's save this. And now we will be importing this at user route.js, because everything inside of the controller will be defined by the routes. Now if you want to use routes separately instead of declaring it in app.js, you have to import a router functionality of Express. So let's start by importing Express. So const express equals to require express, and then const user route will be the express.router. So by using the express router, we can create the custom routes. Now the next step will be to export this. So module.exports, so that this can be used in our app.js, equals to user routes. And let's name this as routes, as well as it will hold multiple routes, right? Now inside of this, we can declare the routes. Before exporting, we can define our controllers over here. So let's save this and then navigate into app.js, and let's import these user.routes, right? So in app.js, after this express.json has been used, what you can do is you can create a new route that will redirect us to this user routes. So app.use, and if request is sent to /API, meaning localhost 8000 /API/users, as this is the users module, right? So if someone sends a request to 8000 /API localhost 8000 /API/users, then we will be redirecting this request to user routes. And let's save this, and also let's comment this as routes. Let's save this as well. And now let's navigate into user.routes and use this register controller over here. Use this register controller inside of user routes. So for that, what we need to do is user routes, and if someone want to send a post request inside of /register, then we will be handling that request by using the register that is on the controllers. So your code should look like this, and let's save this code. So let's try to understand what has happened here. So inside of this app.js, we have imported our user routes, which is a router from Express. Now if you want to import a router from Express, you should be using app.use. We cannot use REST API method over here like get, post, patch and delete, because it will be used inside of this router, right? So for importing the router or Express router, we should be using app.use. Now what we are redirecting Express is, if someone sends a request to localhost 8000 /API/users, then all these requests will be handled by user routes. It can be of any method. It can be of get, post, pass, delete. All method will be handled by the user routes, right? And inside of this user route, we are defining the API, REST API method, and the final URL, which will be handled by the controller. So for this controller to be triggered, the request should come through localhost 8000 /API/users/register. So let me show you how this works in our Postman. So let's start up the Postman and let's create a new collection. So let's create a new collection by clicking here, and then our collection name will be Expense Tracker Pro, right? Let's save this, and inside of it, let's create a new request. So add a request, and the request method will be the post method, and the URL will be http localhost 8000 /API/users and then /register. And by doing this, we are calling the register controller. So let's send the request and hello from register. And this is how you use the Express router functionality. You can take your time and try to understand what has happened if you are still confused. Now by using this Express routes, we are transferring all of these routes into a certain module. By this, we are saving a lot of time and making our code easier to read, maintainable, and we are not cluttering up our app.js by different routes and controllers. And in the large project, it will be very much easier for us to work. I know this because I have worked on CRM software, ERP software, support management, and so many other software, so many large projects, right? And I have always used this modular approach of coding, and I hope this will help you too. So in the next lesson, we will be working on user registration. So I'll see you there. In this lesson, we will be working on user registration. Now, when you are using a modular approach of Node.js, it will be easier for you to navigate the files that you are trying to work on. Like if you want to go to the register.js, you can simply navigate to modules, and then you know that the registration will be inside of users, and inside of users controller you will be getting the register. So it will be easier for you when you are working on the larger projects as well, right? Also, I like to share with you a feature in Visual Studio Code that will help you when you are working on the larger project. Now, if you want to go into any file without navigating through all these folders, because in larger projects there will be multiple modules, hundreds of modules, right? And to search for the specific file, it will be difficult for you. So what you can do is you can type or you can press Ctrl P or Command P and search for this file easily. So this is one of the feature of Visual Studio Code. Ctrl P or Command P and then the file name, and it will navigate you through that file. So let's start working on the registration route. Now the first thing that we want to do here is import the Mongoose. So const Mongoose is require Mongoose, right? And then we will be importing the model as well. So const users model equals to mongoose.model and then the users, and make sure your name of this model matches with the name that is inside of this, right? So the next thing that you want to do is you want to destructure the request.body payload. So start destructuring from request.body, right? And the things that we'll be needing here is the email, the password, and then for confirming the password, we will be requiring confirm underscore password. We will not be entering it into the database, but we will run a validations over here. So email, password, confirm password. Let's check the model. Email, we have email, we have name, we have password and balance. So the password, name, and the balance, right? Now that we have all the necessary data from payload, what you want to do is we want to await, and inside of await, users model that create, and then inside of it we'll be writing name is the name, right? And then the email is the email, and then the password will be the password, and the balance will be the balance, right? Now this await functionality or the await statement requires the function to be async. So let's write that as well and let's save it. So now let's send the request from Postman. So navigate into the Postman and then inside of body, raw, JSON, and inside of it we will be providing the payload data. So name will be the Alex, and then the password, let it be 123456, right? And the confirm password will be 123456 as well, and then the email becomes alex@gmail.com, and then the balance, initial balance of Alex is maybe 100, right? Now let's change this. So it's saying hello from the register. Let's change that as well, but we might have already got the data in our database. So click it find, and there you have it, your results on the database, right? Now let's modify our response a little bit. So instead of this providing this hello from register, we'll be writing user registered successfully, right? Or generally if something is created in database, we send 201. So navigate into the Postman again, and then this time let's rename this first. So this will be user registration, and in Postman 2 we will be following the modular style. So create a folder, and inside of this folder there will be the users module. So rename it to users, and inside of users drag and drop it over here. So inside of users module there is a user registration. So our backend is in sync with the API testing, right? So inside of registration we have our registration page. Now what if I try to send this request again? We have kept our email as unique. You can see at the model we have kept our name email as the unique parameter or the unique value, so that it will not let our database to create a similar value in the same model, right? So if I send the request, then you'll see that our server has thrown an error, and it's saying this alex@gmail.com is already registered. There is a validation error that is thrown by Mongoose, but the error response that you can see over is not understood by the client. How will client be able to know that they have entered the same email address that is already in the database if you show this kind of error? So we need to make our error handling a little bit effective. For that, navigate into our error handler, and then inside of it, what I want you to write is, if there is an error, and if error dot message, if it has a message, then we will be showing error dot message, and else we will be displaying the same error. And if error has a message, then we will be displaying error dot message. Let's save this and let's see the response again, and we'll be providing the same email address over again. So send. Now you can see here that it is a little bit better from what we are getting before. It is a little bit readable, right? But still client will not be able to find the real error. Now to show the real error of Mongoose or the exception that is thrown by the Mongoose, we must detect the error code that is being thrown. And then we need to be able to detect in which key the error is being thrown. And also if the error is thrown by multiple validations, then the approach for displaying the errors are different. And also Mongoose exceptions are of different types like cast error, validation error, validator error, duplicate key error, and so many other types, and each type needs to be handled in a different way. So instead of throwing the exceptions or displaying the exception that is thrown by the Mongoose that is not formatted well, we are going to create our own validations. And this is how we do it. So in our register.js, we need to check if the email that is entered by the user exists in our model or not, right? So for that, what we can do is const get duplicate email, and then to get the duplicate email, we will be checking our user's model dot find one, and then in condition we will be writing email equals to email. So we are checking the data in the database if the email that is entered by the user matches the entry in our database or model or not, right? So if this get duplicate email gets some data from the database, then it means that this email already exists and we need to throw the exception. So if get duplicate email exists, then throw this email already exists. This email already exists. Now let's try sending the request over again. So navigate into the Postman and let's send the request. So you can see this email already exists. So in this code, what we are doing is we are checking for the validations of the data before the creation process. By doing that, we are throwing our custom error messages and not letting the code pass to this create pipeline or create query, right? And by doing this, we are validating and throwing our own custom exception instead of relying on Mongoose throwing an exception for us. So now that we have restricted users with the same email address to register twice, let's check for other validations as well. So we'll be checking for email, password, confirm password, name and balance. So let's start writing our validations. So validations, let me comment this. If email does not exist, then throw email must be provided, right? And if there is no password, then throw password must be provided. And again, if password.length is less than 5, then throw password must be at least 5 characters long, right? And this is our validations. So if there is no name, throw name is required, right? And then if the password does not match with confirm underscore password, then we will be throwing an exception of password and confirmed password does not match, right? So let's save this. Now we have performed all the necessary validations and we have also checked for the duplicate email. Now we are ready to create a valid data on our database. So let's send this query from our Postman. Let's send this request and then see if the data will be created. So I'm getting this email already exists error. So because the alex@gmail.com is already in our database. So let's use zone for now and then send the request. And everything seems to be working fine. So now the user registered successfully. So let's see our database. And we have two entries, alex@gmail.com and zone@gmail.com. So now let's try to send the request by modifying our payload to throw some exception. So let's not provide this alex. So without providing the name variable, we'll get an error name is required that is triggered from our code, right? And let's send without matching the password and confirm password. So the password is 123567 and confirm password is 12356. So if I send it, you'll get an error password and confirm password does not match. So seems like all the validations are working fine. So you might have noticed we are validating our data two times, one from the model and one from the controller. So in model we have written that in this name field, the name is required. This is a required field, right? This should already check for the validation, but we have also written the custom validation code over here in our controller. And the reason for it is we are writing the validation in the controller for displaying the custom error message and for keeping those validations which are not possible for us to include in the model or the schema. And also we have validated the data from the schema, right? And the reason for us to do so is because this is the final checkpoint of the data. If we ever forget to validate any data from the controllers, then the validation in the schema will work and the incorrect data will not be entered in the database. So it is super important that we include the validation logic in the schema as well. And by keeping the validation logic inside of the schema, we assure that the data that is stored in the database is correct and error free. You might have noticed that while saving the data in the database, we are saving this password in the plain text. Now we cannot save this password in the plain text in our database due to security issues. And in the next lesson, we will be learning how we can encrypt the data in the database and why it is important for encrypting the data in our database for assuring the user safety. So I'll see you at the next lesson. In this lesson, we will be learning about encrypting the data in our database. Until now, we have learned about the user registration and how we can handle the user registration. Now it's time that we provide some level of security to our users. It is very important that we encrypt the user password in our database because the user might have kept the same password over in the multiple platforms, right? So if our database get hacked or leaked, then the user account might be compromised in different other platforms, right? The user might be using same password for the social medias, for bank logins, and in many other platforms, right? So if our database get leaked, then if I are saving the password in a plain text, then user account over all platforms will be compromised. So to protect the user information and to protect the user privacy, we should be encrypting these passwords in the database, right? And for that, we will be using the bcrypt package from npm. So let's go ahead and install the bcrypt package. So npm install bcrypt. So after the bcrypt is installed, let's move into register.js. Command P and then register.js. So instead of navigating between all these folders, I am simply typing or pressing Command P or CTRL-P and then finding the file. So in the place where we are saving the data in the database, what we need to do is instead of sending the same password that is entered by user, we need to run the bcrypt hashing code over here. So let's import this bcrypt. So const bcrypt equals to require bcrypt, right? Now instead of sending the plain password when creating an account, what I want to do is I want to hash the password. So const hashed password equals to, then we will be using the bcrypt hashing method. So bcrypt dot hash, and the first parameter for hashing will be the string that you want to hash. So the password, right? The password from our payload. And the second parameter will be the rounds for hashing, which means that how many times this password should be hashed in order to provide you with the hashed password. If you provide a simple number like 1 or a lower number like 1, 2, 3, then the password will be hashed for 3 times or for 3 rounds. Now if you provide a smaller number like 1, 2 or 3, your password will be hashed for 1, 2 or 3 times, right? And it will be easier for the hacker to guess your password. So we should be using a little higher number but not too much higher. Now if you use the smaller number for hashing, then it will be easier for the hacker to guess our password. But if you use a larger number, then it will be difficult for the backend to hash the password because it is an expensive operation and it needs to hash over and over again. So we need to find the optimal hashing round, and the number between 10 to 12 is regarded as an optimal hashing. So we will be using 12 for this. And then as this is an expensive operation and it might delay, we will be using await as well. Without await, we will not be able to hash our password. And now instead of sending the plain password in our create pipeline, we will be sending the hashed password. So let's save this and let's try to send a request from Postman. Payload seems okay. So send. But the zone@gmail.com already exists, so we have got an exception. So let's use Chris for now and send the request. And you can see user registered successfully. Navigate into Mongo Compass and then find. And you can see here the password is now hashed and is stored safely in our database. And this hash password string cannot be ever converted into the plain text ever again. And this is how hashing works. So even if someone has access to our database and if they could see the password, they will only be seeing the hash password and not the plain text over in our database. So you might be wondering, if there is no way to convert this hash string to the original string, then how will we handle the login request of the user, right? If this cannot be converted into the plain text, how will we compare the password? Now there is a way, and we'll be discussing that in the next lesson where we will be working on user login. So I'll see you there. In this lesson, we will be working on user login, but before that, let's clear some data from our database. I have removed all the users from this user model so as to have a fresh start, right? You can also go ahead and delete all the data and create some new user logins. So let's go to the Postman and create a new account first. So our name will be Alex, password will be 12356, and the email will be Alex. Also let the balance be 100. So let me send the request. And user registered successfully. Back to MongoDB Compass, and then we can see the user is registered over here and our password is hashed using the bcrypt, right? Now let's create a new route for user login. So inside of modules, inside of users, inside of controllers, we'll be creating a new route. So new file login.js. So let's start working on login.js. So const login equals to an arrow function, right? And then module.exports login, and then we will be needing the mongoose as well. So const mongoose, because we require mongoose, and then we'll be needing the model as well. So const users model equals to mongoose dot model, and then the users, and the payload will be sent as in JSON using the post request. So we will be destructuring that as well. So const, and the user will be sending email and password for validation. So we will be checking the email and password, and this is destructured from request.body, right? Now we will have an access to request and response variable from here. Now let's include this login in our user routes. So if someone send the request to, let's copy this, and someone send the request to login, then the login route will handle all the logics. So let's save this, and now let's create a new request in our Postman. So let's duplicate this and rename this as user login, and this will be the post request, and the API will be login, and inside of the body we will be having the email and password only. So email alex@gmail.com, and then the password, it's probably 123456, right? So let's save it, and then let's try to send the request. Now we are not sending any request back from our code, so Postman will keep on sending the request. Navigate into the login.js and let's try sending a response. So rest.status 200.json, and inside of it we will be sending status success, and then the message will be user logged in successfully. Right, let's save this, let the server restart, and then let's send the request again. So user logged in successfully, so our route is working fine. Now for handling the login, what we need to do first is to detect whether the email that the user provided for login exists in our database or not. For that, what we can do is const get user await users model dot find one, and then the condition will be email equals to email. So we are trying to find if the email that user provided exists in our database. So this will be an async function, right? And if there is a get user, then we can try login. But if there is not any user with this email address, if there is no user, we are keeping an exclamation, which denotes that if this get user is empty or undefined, then we will be throwing an error. This email does not exist in the system, right? So let's save this. Now let's go back to the Postman and send a request. So let the email be lx2, which does not exist in our database. So let's try to log in. So it says that this email does not exist, right? So back into our code. So you can see that if the email does not exist in the system, we will throw an exception. But if the email exists and if this query could find some data, then the data will be stored on get user. So let's console this. So console.log get user, right? So let's head back into the Postman and send the request over again. So email does not exist. If there is, this email is not found in the database, and if this email is found, then ignore this message for now, as we are not validating or comparing the password. It's only showing this response, a dummy response. But in console, you can see the data that matches with this email address, right? It is in the form of object. So the next step for us will be to compare the password of the user with the password that is entered in our payload, right? But you can see the password in our database is in hashed format, and we will be getting the plain text as a password from the payload, right? So there is no way to compare this password with the password that is in our payload, because one is the hashed string and one will be the plain string. So we need to use the bcrypt compare method, and here's how we do it. So const compare password equals to await, because we are using the bcrypt. So bcrypt dot compare, and we need to import the bcrypt first. So const bcrypt equals to require bcrypt, right? Now we can run the functionality of bcrypt.compare, and inside of this will be some parameters, the data that we are trying to compare. So this is the plain string, right? The first parameters will be the string or plain text. So the password, and then the encrypted string. So encrypted string will be the get user dot password, right? Now this bcrypt.compare function will return either true or false. If the comparison is successful, then it will return true in compare password, and if it fails, it will return false. So if compare password is not true, right, then we will be throwing an error, email and password do not match, right? Let's save this. So if the password does not match or this bcrypt.compare fails, then we will throw an exception of email and password do not match. But if everything is correct, then the code will move to this response sender. So for that reason, we will always keep our success response at the end of the line, right? So this is the success response. Now let's send the request in the Postman and let's check the response. So we will be entering the incorrect password first. So send, and there you can see email and password do not match. Now let's try sending the real password. So 12356 and send, and there you can see user logged in successfully. So this is how you use the bcrypt to compare the hashed password with the plain text password. So now that we have worked on login and register, our users module is almost complete. Now we will be moving towards the transaction module. But in the blueprint, you could see that the transaction module has the protected route. If the user is not logged in, then they will not be able to access the transactions module or anything inside of it, right? So here comes the part of authentication and authorization. So in the next lesson, we will be learning about the protected routes, authorization and authentication. So I'll see you there. So in this lesson, we will be learning about user authentication and authorization. And also we will be learning how we can create a protected route in which only the users that are authenticated can have access to. So now let's go ahead and create a user dashboard API. So inside of modules, as it is related to the user, we will be going inside this users, and inside of the controllers, let's create a new file called user dashboard.js, and inside of it, and module.exports, right? Now this will have an access to request and response, and inside of it, let's send a dummy response for now. So response.status 200, and then the JSON will be status and hello from user register, right? Now let's save this and let's import this in our user routes. So navigate to user routes, and if the request is sent to user routes and the method is get and the URL is /dashboard, then the request will be handled by user dashboard, right? Now let's save this and let's try calling it from our Postman. So navigate into the Postman and duplicate this user login or register, and then our method will be the get method, right? And then the users /dashboard. Save, and in get we will not have the body. Now send the request. So we get the response hello from user register. Seems like we wrote user register instead of user dashboard, so let's change that as well. And also rename the new request to user dashboard. So now let's send the request again, and there you have it, hello from user dashboard. But this route should be a protected route. Without the user login, we cannot allow the user to access the user dashboard. So we need to protect this route, but before that, let's understand how we can authenticate the users for accessing the protected routes. So let's navigate into login.js, and in this part, we should be authenticating the users. So when the username and password matches and when the user is successfully logged in, we need to provide them with the SS token or the key that they can use for accessing the protected routes. And for creating the SS key, we will be using JWT or JSON Web Tokens. So let's go ahead and install JSON Web Token. So npm install JSON Web Token. So now let's import JSON Web Token into our login.js file. So const JSON Web Token equals to require JSON Web Token. Now before using JSON Web Token in our code, I want you to understand what is JSON Web Token and how authentication really works behind the scenes. So to make it easier for you to understand how authentication works and how JWT works, I have created a flowchart for you. So when user logins and if the login is successful, we will be generating an SS token using JWT. So the SS token created by JWT is like a virtual ID card. It will hold the information of the user that has successfully logged into our system. It can hold the information like user ID, name, and many other details that a general ID card would hold. And using that virtual ID card or SS token, a user can access the protected route or protected resources in our server. Now, in order to access the protected resources, every request must be passed through auth checker. Now, auth checker is like a security guard that is guarding the protected routes. And this auth checker will allow access to only those users who have a valid ID card or valid SS token. And if they do not have a SS token or a valid ID card, the request will be rejected and the user request cannot reach the protected routes. And this is how the total authentication system works, right? So let's go ahead and create a SS token from JWT. So in login.js, right above this response, we'll be writing const SS token equals to, and this JWT will have some delay in processing, so await JSON web token or JWT that I prefer calling it dot sign, and this sign method is used to create a valid ID card or valid virtual ID card for our users for authenticating them. So the first parameter will be the payload or the information contained inside that ID card. So for now we will be keeping, this will be an object, so underscore ID will be the get user dot underscore ID, right? And the name will be the get user dot name. So now we have created an ID card with an ID and name inside of it. We have engraved the ID and name in the ID card. Of course, it is a virtual ID card. Now the first parameter will be the data contained by the virtual ID, and the second parameter will be the secret key for verifying the ID card. So you can write any string over here. Let me write my secret key 123. Let's save this, and in the response we will be sending this SS token. So when user logs in and the login is successful, we will be sending this virtual ID that we just created in the response as well. So for that we will be sending SS token as the SS token that we have just created, right? So let's save this and let's try to log in from our Postman. So navigate into the user login, and then with the correct password let's try to log in. So now you can see we have got the status, message and the SS token. Now this SS token is like an virtual ID for accessing the protected routes. Now this SS token, this string that you see over here contains the information of the user, and the information it contains is the ID and the name of the user, and it is encrypted with our secret key. Now you can also decrypt this key and see the data is stored inside of it. So for that, copy this key and in your browser open jwt.io. So once you navigate into jwt.io, in encoded field paste your code over here, and here you will see the stored payload data inside of this SS token. Now you might be wondering, if it is this simple to view the encrypted code and see the data inside of the payload, can someone manipulate the data on their own and access somebody else's account? And the simple answer to that is no. And the reason is, the string that you see over here, the JWT created token or the SS token, is the combination of the payload data which has been encrypted using our secret key. Now they could still go ahead and make changes in the payload data. For instance, if I rename this to Chris, then the JWT token will be generated. But if they try to validate this JWT token or try to use this JSON token for authentication purpose, then the verification will fail. And the reason is, JWT will try to verify this data with our secret key, and it will find the differences between the strings. So it will know that the data has been modified, and it will throw an error of JWT verification failed. Thus, without knowing the secret key, a user cannot manipulate the data that is created by the JWT. So it is very important for us to safeguard this JWT secret key. So instead of hard coding it over here, we will move this to environment variables. So let's copy this, and then inside of env, we'll paste it on JWT underscore salt, right? And we'll be accessing inside of login using the process dot in environment variable dot JWT underscore salt. Let's save this now. So now that we have got SS token while successfully logging in, we can store this SS token somewhere and use this for sending requests in the protected routes. So in the next lesson, we will be learning to create an authentication handler, and we will verify the user JWT token and then allow them access in our protected routes. So I'll see you at the next lesson. In this lesson, we will be learning how we can create a protected route and how we can restrict unauthorized users from accessing the protected routes. So in this lesson, we will be working on authentication middleware. Before diving into the coding of authentication middleware, let's first understand what middleware is in Express. I promised you before that the middleware will have a separate section, and this is the part where we will be discussing about the middleware. So let's try to understand the middleware by using this simple flowchart. In the screen you are able to see three blocks: function 1, function 2, and in between them there is another function which is the middleware. A middleware is a function that acts as a bridge between these two functions. The middleware over here will determine the flow of our code. It will determine whether the code will be sent to this function 2 or the request will be rejected right from the middleware itself. So it will control how the code flows. So in simple terms, we can say that middleware is a function that either restricts or allows the access to the function below it. In our case, we will be creating an authentication middleware that will handle whether the request that is coming from the client is to be sent to the protected routes or not. It will have all the validations including the JWT validation, and it will determine whether the request coming from the client is to be sent to the protected route or to the functions of a protected route, or to deny it or throw an exception. So let's go ahead and create an authentication middleware. For that, we will be creating a new folder that will be the middleware, and inside of it we will be creating a new file called auth.js. This will be our authentication middleware. So const auth equals to an arrow function. This is a function after all. So module.exports and then the auth. Now before actually using it for the authentication, let's see how a middleware typically works, right? Now to show you how a middleware works, I'll be introducing a middleware in our user routes. So navigate into the file, and I'll be introducing this auth middleware right above this user dashboard. So right over here. So user routes dot, and for using the middleware we will be using the keyword called use, right? And we will be using the auth middleware, and import this from middleware/auth. And now we are using this auth as a middleware. Now everything below this line will be controlled by this authentication middleware. So when we send a request from a Postman to this user dashboard, this authentication middleware will run first, and it will determine whether to send the request to this dashboard or not. So let's try that. In this authentication middleware, I'll be writing console.log and then hello from middleware. Right? Let me save this, and let's go into our Postman, and then let's send a request to user dashboard. Now you can see that request keep on going and there is no response. Now if you see at the console, you can see that there is a message called hello from middleware. Now you can see that before this route, before we can reach this route, our authentication middleware is running, right? And this authentication middleware can control whether to send the request to this route or not. Now if you want to send a request to this route right before this, then you should be using the next functionality. So the things that we will be getting an access in the middleware is request, response, and then next function, right? And if you want to send the code below this middleware, or if you want to release the request from the client below all the functionalities of the middleware, what you need to do is you need to pass the next function. You need to run the next function, and by doing next, you are allowing the code to move downwards. So if I go into this route again, if I send the request, you can see hello from the user dashboard, and also you will see hello from the middleware. So this middleware has run, and this middleware has allowed the access of our code to move into this routes as well by using the next functionality. Now if you don't want the functions that are below this middleware to be executed, what you can do is you can simply throw an error over here. So throw can't do this now, and then let's comment this next, and let's try to send a request into the user dashboard. So you can see we are getting the error can't do this now, which is triggered by the middleware. The middleware has restricted our access to this user dashboard, right? And this is exactly the thing that we are trying to do. We are trying to run all the validations or authentication validations inside of this auth code, so that if the user is not authenticated, then we will restrict their access to the protected routes. So everything after this authentication middleware will be the protected routes, right? So now that we have an idea of what a middleware is and how it executes, let's look back into this app.js file. And this app.js file, we have been using the middleware. The middleware that we have been using in app.js are app.use express.json. This is also a middleware that has allowed us to access the JSON data from the payload. Another middleware that we are using here is the error handler. Now if you navigate inside the error handler, you can see that we are also running this next functionality here. So you can see here, if there is an error in this code, we are sending an error response. But if there is no error, we are allowing the code to move forward to all the routes or functions below this error handler, right? So we have been using middleware from a very long time, but we finally understand now what is middleware, and now we will be working on authentication middleware in the next lesson. So I'll see you there. In this lesson, we will be working on our authentication middleware. Now in previous lesson, I said that when a user logins, we will provide them with the SS token that acts as a virtual ID, right? And if they want to access the protected route, they need to send this SS token to every request. Now let's find a way to send this SS token in the request. So let's copy this SS token, and as our user dashboard will be the protected route, let's navigate into it, and we'll be sending our SS token in the authorization tab. So we'll not be sending our SS token in the body or any other place. We'll be sending it through the authorization headers. So navigate into this authorization, and in the type we'll be sending the bearer token or selecting the bearer token, and in this token we'll be writing the SS token that is provided by the user login, right? Let's save it, and now let's navigate into the auth.js, and then we will be seeing the headers that we are receiving from the request. So remove this code, and instead of this we will be consoling. So console.log request.headers, and this time we will not be reading the body, but we will be reading the headers, and our authorization or the SS token will be thrown or be provided at the headers. So let's console that, and we will be allowing to run this next functionality. So also allow this next, and again send the request. So let the server start, and after it started, send the request over again. So hello from user dashboard, and here you can see we have received the request.headers, and inside of request.headers there is an authorization key, and inside of this authorization key there is a string called bearer, and after this we have our SS token. So we need to take this SS token out of the request. In this authorization header, you can see that the string that it contains is the bearer and then the SS token. But if you look at the Postman, we are only sending the SS token, right? But we are using the type authorization type bearer, so this bearer text will be automatically appended to this authorization header. So what we need to do is we need to take out this authorization SS token from this authorization. So what we can do is we can create a new variable called SS token. So const SS token equals to request.headers.authorization, right? Let's console this, and let's send the request from Postman again. And here you can see we are getting the SS token, but we still have this bearer, so we need to remove this bearer and white space from our SS token. So for that, what we can do is we can use dot replace, and then replace bearer and space with an empty string, right? So let's again console this SS log, SS token. So after the server has started, let me send the request, and then we have the actual SS token that is sent to us. So now that we have retrieved the SS token from the request headers, we can verify the SS token using the JWT verify method. So first, let's import the JWT or JSON Web Token. So const JSON Web Token equals to require JSON Web Token, right? Now we will take this and we will use this to verify our code. So const verification or JWT verification. JWT verification equals to JWT.verify or JSON web token dot verify, and then inside of it we will be having the token as an string. So our token is the SS token, right? And in the second parameter we will be having the private key, right, or the JSON token secret, and in our case process.env.jwt_salt, right? Now let's save this, and in this way we can verify whether the SS token provided by the client is actually the valid SS token or not. So let's console this JWT verification now, and let's remove this console log as well. So let's save this and let's try to send a request again. So let's go into our Postman and let's send the request. And you can see that this JWT verification has provided us with the data that is stored in the payload. Now if there was an error, or if you try to manipulate this, let me remove this last character from our JWT verification, JWT SS token. So let me remove this Y and let me send the request again. So if I send the request, it fails with invalid signature. So if anyone tries to edit or manipulate the data in SS token, then our JWT verification will fail. Now if the SS token is successful, then this JWT verification will hold the JWT payload, right? So let's rename this as JWT_payload, right? And let's save this, and we'll be consoling JWT payload over here. So now if I send the correct correct SS token, then I can see that we have an JWT payload over here. If you see at the response of Postman, if the JWT verification failed, it's showing invalid signature, but instead of this we'll be sending our own custom error. So for that, what we need to do is we need to wrap this with try catch. So try doing this, and if this throw an error, we will be catching it, and then we will be displaying our own error, and we will be displaying response.status, and this time we will be using the HTTP error status code 401, which means unauthorized, right? .json, and then inside of it status, and then failed. After this, message will be unauthorized, right? Now let's save this, and don't forget to write the return statement over here. Otherwise your function will move downwards to this next and everything will be messed up. So let's remove this JWT as well, and let's try by sending the wrong SS token. So I believe this is a wrong SS token. So let's send the request, and here you can see we have a 401 unauthorized error, and the message is showing unauthorized. So we are able to send the custom error by handling the invalid signature error, right? So now let's see what happens if I entirely remove this authorization. So no auth, and let me try sending the request. So you can see cannot read properties of undefined replace. So this error is being triggered by this SS token, in which we are not sending this authorization header for now. So this authorization is undefined, right? And this replace functionality cannot run on undefined. So it is throwing an exception, and not having authorization is also an unauthorized request, right? So let's move this code inside of this try block. Let's save this, and then now if I try to send a request without this authorization, I'll be getting the same error message. And it is because the JavaScript errors are also handled by this try and catch block. If there is any JavaScript error, then it will be handled by the catch block, and inside of the catch block we have written our custom error message. And another important thing this auth middleware should do is to pass this JWT payload in other functions that will be executed after it. So what we will be do is we will be using request.user equals to JWT_payload. Right? We are setting the request.user, we are creating a user object in the request itself, and it will have a value of JWT payload. So now that we have an object, user object in the request, all the routes after this auth middleware will be able to access the request.user object. So now let's go inside this user dashboard, and inside of this user dashboard, let's console request.user, and let's see if we are able to access this request.user object that is set by this auth middleware. So let's go into the user dashboard, and then let's use the bearer bearer token, right? And then let's modify this to make this correct, and then send the request. And you can see hello from the user dashboard. So if you look into the console, you can see that we are able to access this request.user object that was set by this auth middleware. So now that we have access of this virtual ID card in our routes or in our functions, we can show the relevant data to the users. So in the next lesson, we will be constructing the user dashboard. So I'll see you there. From this lesson onward, we'll be working on Expense Tracker Pro functionalities. So now that we have an access to request.user object that is provided to us by this auth middleware, we can use that request.user object and then provide user with their own dashboard. So let's work on that. So now let's navigate into the user dashboard. So Command P or Control P and then user dashboard, right? So currently in our user dashboard, there is a response called arrow from user dashboard. So in the user dashboard, we want to display the profile of the logged in user, right? So for that, what needs to be done is let's import the Mongoose first, because we will be running database operations here. So const Mongoose require Mongoose, right? And inside of this, we'll be working with the users model. So const users model equals to Mongoose dot model, and then the users, right? So now we will be querying our database to find the user that has logged in, and we will be displaying the user details over in our response. So for that, we need to detect the logged in user. And as you can see in our user route, this user dashboard is running after this auth, and this auth middleware is setting this request.user object as an JWT payload, right? So we will be able to access the request.user from our user dashboard, and inside of this request.user object we will have an ID of that user. So let's try to send the request and see what is inside of request.user again. So let's start up the server. So npm start. So from Postman we will be sending a request to user dashboard. So hello from user dashboard, and in console you will be able to see the request.user object that is set by our auth middleware. So in this request.user object, we have an ID of logged in user, right? So we will be querying our database with this key and value pair. So for that, what we can do is const get user equals to await, and as this is an await statement, this will be async, right? Await users model dot find one, because we are finding one ID only. So inside of it, we'll provide a condition that underscore ID in our database matches with the ID stored in this request.user object. So underscore ID equals to request.user.underscore ID. And we'll be sending this get user object in our response. So status will be success, right? And in data, we'll be sending this get user object. So now let's try to send a request from Postman again, and let's see the response. So let the server start, and after it's started, let's send the request. And as you can see, we will be getting all the details related to that user from our database. Now in this response, we are getting all the data related to that user that is saved in our users model, right? But you can also see that we are also getting this password field and value. And it is very important that we do not send this type of critical data in the response. It might cause some security concerns, right? Although our password has been hashed using the bcrypt, but it is not recommended that we send any critical information in the response. So we need to filter out the data that is displayed in the response. So for that, what you can do is navigate into this user's dashboard, and then where we are running the query, we will be chaining this select function, right? And inside of the select, there will be a string, and the string will determine what type of data we will be needing in the response. So the field that we need are the name field, balance, right, and the email, and we will not be needing the password in this response, right? So now let's send the request again. So you can see that we are only getting this name, email and balance field that we have declared in our select function, right? And this underscore id is a unique identifier of the data, so this will always be displayed. So currently in our user model we only have few fields, right? So it was easier for us to write this name, balance and email, but in schema there might be more than 100 fields, right? So writing each field one by one is a bit of a hassle. So what you can do is you can restrict some field or you can not display some field by simply using minus and then the field name. And by doing this you are excluding this password field from this query. Now if I send a request again, I can see that this password field has been excluded but all other fields are being displayed. And if I want to exclude multiple fields, I can simply type those field name over here like this. So now we will not be seeing password and name of the data. So send. So you can see here name and password field has been excluded from the response. Now this will become handy when you are working with a model that has lot of schemas or lot of fields, right? But for now we will be only excluding this password field. So let's remove this. Now if you look into the response again, you can see that we have got this underscore id which will be always displayed, and then we are getting this underscore v, which means the version of the data. If I made a changes to this data, then the version will be updated every time I make a change to this data, right? And this version checking is default feature of Mongoose, so leave it as it is. And like this version checker, there are other features of Mongoose as well. So I want you to navigate into this users model. So inside of models, users model, and in the second parameter, the first parameter will be the schema, right? And in the second parameter, if you provide timestamps equals to true, then Mongoose will automatically provide you with the created and updated date. So let's see how it's done. So let's try to create a new account. So navigate into the Postman, inside of users, user registration, and in user registration we'll be creating a new account of Chris, right? And Chris, let's send this. So user registered successfully, and in MongoDB Compass, if you refresh this, you can see that Mongoose have added two new fields, created it and updated it. Now this will come in handy when you are trying to detect when the data is created and when the data is updated recently. So when we are creating the model, let's keep this timestamps true from now on, right? Now you might have noticed one thing, when we are logging in an account, we are getting the SS token, right? But when we are creating an account, we are not getting the SS token in the response. And typically when you register an account on website, you are automatically logged in, right? In most of the cases. So let's send the SS token from our registration route as well. And we'll be doing that in the next lesson. So I'll see you there. In our user registration API, we are not sending the SS token in the response. Typically when you create an account in a website, you are automatically logged in, right? So let's fix that. So let's navigate into the user registration page or register.js, and right above this user registered successfully, we will be sending the SS token by using JWT. So let's import JWT over here. So const JSON web token equals to require JSON web token, right? Now let's use this, but instead let's copy the code from this login. We are doing the same thing. So copy this and then paste it in register.js. And in this page we do not have access to this get user because we are not finding any ID. Instead we are creating the ID, right? So what you can do is you can assign this creation process a variable. So const created user equals to user model.create. Now this created user will hold the value of the user that is recently created. So we will be, instead of using this get user, we will be writing created user._id and created user.name. Now let's save this and let's send this SS token in the response as well. So SS token is the SS token. So now let's create a new account. So our new account will be the name John and the email will be john@gmail.com, and let's send the request. So the account is registered and we are getting the SS token over here. Now let's copy this SS token and paste this in jwt.io to see the virtual ID card of the user, right? So in jwt.io, let's paste this over here. And here we have a JWT payload of John. So now that we have an SS token of John, let's copy this, and using this SS token, we will be querying the user dashboard of John. So paste it over here and send the request. Now currently we only have one route that is protected, right? But when we are creating a transaction part, we will be having multiple route, and pasting this SS token every time in each route is little bit of hassle for us, right? So let's create a new environment in Postman so that we can keep our variable and we can use those variable and reduce the task for copy and pasting every time. So go into this environment and let's create a new environment. We'll rename this as Expense Tracker Pro env environment, right? And the first variable will be the URL as we learned previously. So URL will be http localhost 8000/API, because everything will start with the API in our end. So, and the second variable will be the SS token. In this SS token, let's paste this newly created SS token. So let me copy this and then paste it in our environment inside of ETP environment. So paste it over here and here as well. So save this, and now we will be sending this SS token variable in request.header. So navigate into collection, but first change this environment to ETP environment. Save this and navigate into this user dashboard. And in user dashboard, instead of providing this string or this SS token, we will be using the dynamic variable called SS token. So two curly braces and then this SS token, and save this. Now by using this SS token from our environment variable, we are reducing our task of copy and pasting the SS token every time. Now if we have multiple protected routes, we can use the same SS token that is stored in the environment variable, and this will also help us when we are logging in different users. For instance, if I go to this user login and I log in this Alex, let me send the request. Now I have an SS token of Alex, right? So let me copy this and let me change this SS token to Alex. So paste this and also here paste this variable, right? So I do not need to change this SS token every time. This will have an updated value, right? So let's send this, and you can see that we have an SS token of Alex. Now if I log into John, I can simply copy this and then use it in the environment variable, right? And then all of my protected routes that needs request authorization header will be automatically logged in using the zone account. So this is very handy when we are working with multiple user logins or when we are trying to test login of different users, right? But it would be much easier if this SS token is automatically updated when user logins or register, right? So instead of updating this SS token every time, it will be easier if the Postman does it for us. And this is how you do it. So in this user login request, go into the test tab, and in test we can write the code to manipulate the environment variable of our Postman. So here what you can write is pm, meaning postman.environment.set, and then the first parameter will be the key, so SS token. We are trying to update the SS token, and second variable will be the value, right? And the value that we want to save here is from the response, right? So now let's assess the response. So pm.response, and this response will be on JSON format, so we need to run .json, right? JSON function, and then we will be assessing this variable from SS token from here. So SS token. Now let's save this and let's try to log in using the Alex account. So login, and this SS token has been updated in our environment as well. So navigate into user login again. So login with Alex account, right? And then go to user dashboard and send the request, and you will see Alex. Now let's try to modify using the Chris, zone, right? Save this, and this SS token will be automatically updated in the environment. So this user dashboard is using this SS token as a dynamic variable. So if I send the request, we will be getting the account details of John. And also we are sending SS token from this user registration. So let's copy the text of this user login. So copy this and paste it to this user registration as well in the test tab. So let's save this. And now if we create an account using this route, then the SS token, newly created SS token, will be automatically assigned in our environment. So let's go in body and let's try to create a new account. So the name would be Tom of a new account and the email will be tom@gmail.com. And let's provide them with balance 5 and then send. And there you have it. We have an SS token over here, and this test script has overridden our SS token using the newly created SS token. So if I go to the user dashboard and if I send this request, you can see I am able to assess the login of this new user. So we have balance 5 and this account belongs to Tom. And this is how you create environment and run tests in an effective way. So from the next lesson, we will be working on the transaction module. So I'll see you there. In this lesson, we will be working on JWT Manager for centralizing the JWT signing process. So if you look into the registration page and login page, you can see that at the end of this code, we are using JWT to create an SS token, right? We are doing the same thing in login and register. Now, if I want to keep some other field in the virtual ID card or the SS token, then I need to modify both the route, login and register. So instead of doing this, what I want to do is I want to refactor it in a single code. I want to create a JWT manager and I want to centralize the JWT signing process. So for that, what I can do is I can create a new folder and name it as managers, right? And inside of managers, I'll be creating a new file and the file name will be JWT underscore or JWT manager.js, and inside of it const JWT manager equals to an arrow function and then module.exports JWT manager. So now let's copy this code from login, this JWT signing, and paste it over here, right? And I did a little mistake here. I got this JSON web token confused with another package. This JSON web token package do not need an await statement. It does not delay the process. So we will not be using await. And in this code, we do not have access to this get user. So instead of get user, what we will do is we will be passing the user data while calling this function from other codes, and then we will be using this user as getting ID from the user and then name from the user, and this function will return the SS token, right? And as we are using this JSON web token over here, let's import this class as well. So const JSON web token equals to require JSON web token. Let's save this. So let's save this. And now we'll be modifying our JWT signing in login.js. So instead of SS token to be a JSON web token.sign function, what we'll do is we'll replace it by JWT manager and make sure it is imported from managers. And inside of it, we'll be passing the user account or user object. So in this case, this get user is the user object. So we'll be passing it over here, right? And then let's save this. Now what this does is this JWT manager will get an access to this get user or the user object, and it can get ID and name from that user. And I want to do the same with the registration process as well. So navigate into the register.js and replace this code with JWT manager, and let's import this here as well. So make sure it is imported. And then what I want to do is I want to pass this user object, and in this case this created user is the user object. So let's pass this and let's save the code, right? And by doing this, we are centralizing our JWT signing process. Now the advantage of centralizing the process is if I want to introduce any variable over here, let's say if I want to include the balance in our JWT or virtual ID card, I can simply access user and inside of the user the balance key, right? I do not need to modify the JWT signing of login and register. So it is always recommended that you refactor the code that are being repeated in your code base. And by centralizing the JWT signing process in JWT manager, we are refactoring and writing less code and making our code more maintainable. And also we are maintaining consistency of SS token over login and register controller. So let's navigate into the Postman and let's try testing the updated code. So let's go to the user login and we are currently logging in Zone. So we have an SS token. So let's go to the user dashboard and here we have profile of Zone. Again to the login and instead of John we will be writing Chris and logging in the Chris account. And then if I access the user dashboard, so everything seems to be fine on this user login. Let's go to the user registration, and this time we will be registering Bob. So Bob, and the email will be Bob. So let's send the request, and we have got the SS token. And if I navigate into user dashboard, and here we have the SS token of Bob and the user detail of Bob. So everything seems to be working fine, and our centralized JWT manager is also working fine. And let's see what data we are getting from the SS token. So go into the environment, and let's copy this current value and then see it on jwt.io. So paste this over here, and here you can see the balance is also included, right? And now by centralizing our JWT signing process, if you want to introduce any variable, you can introduce it over here, and then login and register page will automatically include those in the SS token. And currently we do not want this balance over here, so let's remove this and save our file. And this is how you centralized your JWT signing process. And from the next lesson we will be working on more functionalities of Expense Tracker Pro, so I'll see you there. So until now we have learned how we can handle the user registration, user login, user authentication, and so much in between, right? And this completes our first module, the user module. And now we will be working on the transaction module. But before that, let's have a visit at Expense Tracker Pro Blueprint. So here it is. We have completed the first module, the user module. We have worked on user login, user registration. We have worked on JWT authentication, and we have constructed the user dashboard. Currently in user dashboard, we are only displaying the balance and profile information. But after we have worked on this transaction module, we will also be showing the recent transaction in our dashboard, right? And with this, we have completed our first module, the user module, and it's time for us to develop the second module, the transactions module. And as you can see, all routes inside transaction module will be the protected route. We will only be allowing the users who log in or who has an SS token to get access to the income and expenses part. And all other requests without the authorization header will be handled by our auth middleware, and we will throw an exception of not authorized. And this is how we want to proceed. At first we will be creating the transaction model so as to save the transactions, right? And then we will be working on adding income and expenses in that transactions, and then we will be querying the database for income and expenses related to that user. We will be adding all the income and expenses to get an aggregated view, and we will learn so much more in between. So I'll see you at the next lesson. So let's start working on transaction module. At first, we will be creating a transactions model so as to store the transaction data of our users, right? So let's go ahead and create transactions model. Now, instead of creating a new file, I will be replicating this. So copy paste and then rename it to transactions.model.js, right? So now let's remove these fields as we will not be needing this in transactions model. Now let's rename this users schema to transactions schema, and use this same schema over here, and our model name will be transactions, and this user model will be transactions model, right? And we will be exporting this over here. Now we will be constructing our fields over here. So the first thing that we will be needing in the transaction schema will be the user underscore ID, and this user ID in the transaction will hold the user ID that is inside of the users model. And the reason for it is transactions model and user model are interconnected. Only the users that are available in our users model will be able to create the transactions, right? So there needs to be a link between the transactions and users, and so we are using user underscore ID for denoting the user ID inside of our transactions model. So the type of this user ID will be mongoose.schema.types and then the object ID. Now instead of saving the user ID in transaction schema as a plain string, we will be using object ID type of Mongoose, right? And also we need to provide a reference to the user model. So for that, next key will be reference, and inside of the reference will be our model of users, and this will be a required field, so required true. So by providing the reference, we are linking this user ID object with the user ID of users model, right? Now other fields that we'll be needing in the transaction are the transaction amount. So this will be of type number, right? And it is also a required field, so required true. And the next field we will be needing is the transaction type, so transaction underscore type, and this will be of type string, and it will also be a required field, so required true, and then it can only hold the value of income or expense. So we will be saving either income or expense over here. So if you want to restrict this field for using only certain variables or certain values, then what you can do is you can use the enum. So in this field I only want either income or expense, right? And if you try saving any data except income and expense, then it will throw an validation error. So the next field that we will be needing is the remarks. So we will want to ask the user what is this transaction about. So this will be of type string, and this will also be a required field, right? And the next thing that we will be needing here is the transaction date and time to see when the transaction had occurred. But as we are using timestamps true, it is automatically created by Mongoose, so we do not need to write that. So I think our schema of transaction module is complete. So now let's initialize this transaction model in our app.js. So in this model part of app.js, we will be requiring /model and then transactions.model. Now let's save this and let's start our server. So server is already running in my terminal. So if I navigate into the MongoDB compass and if I refresh this, I'll be able to see the transactions model or transaction collection over here. So now that we have our transaction model, let's go ahead and create some routes for handling the transactions. So I'll see you in the next lesson. So in this lesson, we'll be working on income handling functionality of Expense Tracker Pro. So in this part, when user logs in and then enters the income, it will have an effect on the balance of the user. Also, it will be creating a transaction record in the transactions model. So let's go ahead and create a add income route. So inside of these modules, add income is a part of a transactions, right? So we'll be working inside of this transaction module, but before creating a controller, let's create a route. So new file, transactions.routes.js. Now let's copy the code of user routes so that we do not have to write this all over again and paste it here. So now let's make some changes. We will not be needing this login and register and this dashboard as well, and also remove all the imports over here, right? And now let's rename this user routes to transaction routes. So Control D to have a multiple cursor. So transaction routes, and then I think we are done in this route. Now let's import this route in our app.js. So inside of this app.js, in the routes part, we'll be using app.use/API, which means localhost 8000/API, and then our module is transactions, right? So we'll be using transactions, and everything that lands through transactions will be handled by our transaction routes, right? Make sure this is imported. Now let's save this. Now in transaction route, let's create a controller. So for that, inside of this transaction module, new folder, controllers, and inside of it, we will be creating our first route, add income.js. Inside of it, const add income equals to an arrow function, and then module.exports add income, right? And this add income will have an access to request and response, and inside of this response.status 200.json status will be hello from add income, right? Let's save this and import this add income in the transaction routes. So if someone sends a request to transaction routes dot post using a post method, if someone access to add income, then our add income controller will be handling this request. Now let's save this and make sure you have not removed this authentication middleware from here, because all of the routes inside of this transaction will be protected, right? So if you remove this, this will be a public route, and then our add income will not be able to access request.user, so everything might fall apart, right? So now let's try to send a request to this add income using our Postman. So navigate into Postman and create a new folder inside of this Expense Tracker Pro, because we are working on new module, right? So add folder, and this folder name will be transactions. Rename it to transactions, and then inside of it we will be having an add income route. So let's copy this user dashboard, so we do not have to copy all this authorization logics. So copy this, as it is, this is also a protected route, right? So inside of a transaction, paste it over here. So you'll have an user dashboard copy, rename that to add income, and this will be a post request. And inside of this authorization tab, we are sending a bearer token and then the SS token that will be saved by our environment variable, right? And here we will be changing our routes as well. So API slash users, instead of this API slash transactions, and then add income. Save this and let's start our server. So after the server is started, let's send the request. So as you can see, hello from add income. Now if I try to remove this authorization, no, then I will be getting the unauthorized error, right? Because we are using auth middleware in our transaction route. So let's work on this add income controller. So let's import Mongoose first of all. Const Mongoose, just to require Mongoose. And then inside of it, we will be assessing the model, users model. It will be Mongoose dot model users. And then we will also be assessing another model. So const transactions model equal to Mongoose dot model transactions, right? Now make sure that this transaction matches with the name that is written in the transaction model. So we have these transactions over here, and so everything should work fine. Make sure that these are exactly the same, even a slightly spelling mistake. For instance, if I use transaction over here, then it will not work because this model is not available, as transactions is initialized, not the transaction. So make sure you are maintaining the consistency. So let's save this. So now let's have a look what are the things that we'll be needing in the payload from the request. So let's navigate into transaction model and let's see the fields. So we'll only be needing this amount and the remarks. This transaction type and user ID will be entered by our code. So now let's destructure the payload. So const, and then inside of it amount and remarks, right? And this will be destructured from request.body. And then if there is no amount, then throw an error of amount is required, right? And if there is no remarks, then we will throw an error, remarks is required. And if the remarks dot length is less than 5, throw an exception. Remarks must be at least 5 characters long, right? Now let's modify this response as well. So in this we'll be writing success, and in message we'll be writing income added successfully, right? Now before using this database, let's see if our validations are working correctly. So let's send a request. So if I send a request without the payload, I should be sending this authorization. So bearer token and SS token. So send, and then amount is required. So navigate into body, and then it will be of JSON type. So inside of it, we'll be needing an amount key. Amount will be 100, right? And then the remarks will be hello. And this is a 5 characters, so everything should work fine. And here you can see income added successfully. But if I remove this and send the request, the remark must be at least 5 character long. And there is one more validation that needs to be done. This amount should always be in number. If I provide A, B, C over here we are getting the success response, but amount is not in the type number. So let's check for that validation as well. Now we could write the validation logic ourselves, but instead we will be using a simple package called the validator. This validator package is a lightweight package. It will help us check for different type of validation, like whether the value entered is number, is a valid email, is only characters, and so many different other validations, right? So to make our validation easier, let's import this package in our project. So let's close the server now, and then npm install validator. So let's import this validator in our add income. So const validator equals to require validator, right? And we are trying to check if the amount is a valid number. So to see all the validation option that is available in validator, we can navigate into this npm of validator and we can access the documentation here. So we can check all of these different things. So currently we are needing is numeric, right? This function will check whether the value entered is numeric or not. So let's use this. So before using the validator, let's see how a validator responds. So console.log, and inside of it validator dot is numeric, right? And inside of it we will be sending the value, so amount dot to string. Now it is important to convert the value into string, because without the string this validator will not run. So make sure whenever you are using this validator you must convert this value into the string first. So let's check the response of the validator. So save this and let's send the request from Postman. So send, and here you can see income error successfully, but in console you can see that validator has responded with false, because the ABC is not a number, right? So let's try sending a number. So let me send 1 2 3 and then send, and then you can see it has responded with true. So this means that this validator will respond with a boolean. So you can use this in this way. So if validator dot is numeric, and inside of it amount, and don't forget to do to string, right? And if this is not the case of it responds false, then meaning that it is not a numeric. So throw an error, amount must be a number, or amount must be a valid number, right? Now let's remove this and then save again. So send the request. If I do 1 2 3, then income added successfully, but if I try to send A B C or anything like that, then amount must be a valid number. So now let's start working with database. So first thing that we want to do is we want to create a record in transactions. So await transactions model that create, and we'll be sending the creation object over here, and the field that we'll be needing is, let's have a look at this transaction.model user ID. Now the user ID we will be getting from request.user, as this is provided by authentication middleware, right? Dot underscore ID. And by doing this we are trying to assign this created transaction to this user, right? Now the second field that you will be needing is the amount. So amount will be the amount from our payload, and the remarks will be the remarks from the payload, and then the transaction type will be the income, right? Transaction type will be the income. As the user is navigating through add income route, so the transaction type is income. So let's save this and let's try to send a request from the Postman. So remarks is received from a friend, right? And the amount is 100. Let's send the request. And here you can see income added successfully. Now navigate into MongoDB Compass and refresh this page, and you can see that a new transaction is created, and this transaction belongs to this user only. By keeping this user ID in transaction, we will be able to determine which user has performed this transaction, and it will help us link the user with transactions. So let's see to which user this transaction belongs to. So open a new tab, and in this tab we will be opening the users. So we'll have a users open here and then transactions open here. So double click this user ID and you will be able to copy this. Now navigate into this users tab, and by using this filter you can search for that particular user. Now by using this filter you can search for any data in this model. For instance, if you want to see only those users whose balance is 100, then what you can do is provide an condition object over here. So inside of this object we will be writing balance and then the value. So click at find. So here we are only getting the data whose balance is 100. You can also provide multiple conditions over here. For instance, if you want the balance 100 and name to be Alex, then you will be getting the required data only, right? So we are trying to search for this user ID in this users tab, right? So what you can do is open a object, and then inside of it you want to write underscore ID, and you cannot simply paste this over here because this will be treated as a string, but this is an object ID, right? So you need to wrap this copied string with object ID. So object ID, and inside of this you need to provide this object ID and then find. So this transaction belongs to Bob. So this is how you use the filter option. So you might have noticed that while creating this Bob account, we provided Bob with balance 5, right? But we added an income in the Bob account of 100, but it is not updated in the balance of Bob. So for adding the balance when an income is entered, what we can do is we can run another query which will update the data of users model. So navigate into this add income, and after the transaction is created, what you can do is await, then users model dot update one, right? And the first parameter will be the condition. So underscore id will be the request dot user dot underscore id, right? And then in second parameter we'll be providing the data to update. So in this you cannot simply write balance equals to amount, because this will update the balance to this new amount, but we are adding the income, right? We are trying to add a certain amount in the existing balance, right? But this will replace the balance. So what we can do is we can use an operation called inc means increment, and we'll be passing an object over here that needs to be increased. So in our case balance, and balance will be increased by the amount. And this is how you add a data to the number field in database, right? And in the third parameter, don't ever forget to include run validators true, because without it the validation in schema will not work. So let's save this, and now let's try to add an income to Bob account. So go into the add income tab, and then this time we will be adding only 10. So the expected balance will be 15, right? So send the request, and it is received from friend. Now it will create a transaction in this collection. So you can see the new transaction with amount 10, and if you refresh this, then you can see the balance of Bob have been updated to 15. And this is how you work with multiple models in a single file. And this completes our add income route, and in the next lesson we will be working on add expense. So I'll see you at the next lesson. In this lesson we'll be working on add expense functionality. So whenever user adds an expense, it will have a negative impact on the balance, right? And it will create a transaction data with a transaction type expense. So let's start working on it. In modules inside of the transaction, let's duplicate this add income. So copy paste and then rename it to add expense, right? Now let's rename this add income to add expense. So we have add income over here and then here. So select it and Control D to have in multiple cursors. So add expense, right? And all the validation will work as it is. And in this part, we will be renaming this income to expense. Now in this query, what we are doing is we are finding this user ID and then we are adding a balance into it, right? But in Mongoose or MongoDB, there is no operator like decrease. We have increment, but we do not have decrement. So there is a workaround. What we need to do is we need to multiply this amount by -1. By doing this, we are subtracting the amount from the original balance. And let's name this to expense, added successfully. And now let's include this add expense controller in the transactions route. So if someone sends a request, post request to add expense, then our add expense will handle it, right? Now let's go into the Postman and create a new route. So duplicate this add income and then rename it to add expense, right? And the route URL will be add expense. Save this and go into the body and let's modify our payload. And as this is an expense, let's change this. So let the amount be 10 and the expense type be movie ticket, right? Let's save this, and if we send the request, we should be able to see that the balance will be updated to 5 because we are deducting 10 from our Bob account, right? So send, and then expenses added successfully, and then if you refresh this, you'll be able to see 5, and it will also create an entry in transactions, and if you click at find, you will be seeing this, and this is a transaction type expense, and the amount is 10, which has successfully been deducted from the balance of Bob. So what if I send minus in the expense? So navigate into Postman and let me try sending -10 from here. So send the request, and here you can see that the expense have increased the balance, but this is not accepted. Expenses should not be able to increase the balance. It has increased because minus and minus is plus, right? So we should not be accepting the negative value in expense and also in income. So let's fix that. So navigate into the add expense and let's validate. So if amount is less than 1, then throw an error, or 0, throw an error. We are not allowing the negative. So amount must not be negative, right? And let's copy this validation and paste it in our add income as well. So we are taking only the positive amount, and in income we are adding it, and in expense we are deducting it. And this is how it's done. So let's send the request again, and here you can see amount must not be in negative. Expense is negative, but we are deducting it in our code itself, so we are not allowing user to send the negative value. And this completes the adding of income and expense. And in the next lesson, we'll be working on getting income and expenses using a get method. So I'll see you at the next lesson. In this lesson, we'll be working on getting transactions of the user. Now we won't be creating get income and get expenses separately, but we will be creating one route called get transactions, and then we'll be using query string parameters for getting the desired value. So in this lesson, you'll also be able to learn query string parameters. So let's get started. So let's create a route called get transaction inside of the transaction module. So inside of controllers, new file, get transactions.js. So inside of it, const get transactions equals to an arrow function, and module dot exports get transactions. Let it be transactions, and then this transaction will have access to request and response. And currently we will be sending request.status 200.json and then status transactions only for now. Now let's import this module in our transaction route. So if someone sends a request to /transactions using the get method, then it will be handled by get transactions. Right? Let's save this and let's create a new route in our Postman. Navigate into the Postman, and inside of this transaction module, let's copy this add expense, and now let's rename this to get transactions, and this will be of get method. There will be no body, but there will be an authorization header over here because this is a protected route. And let's change the URL to transactions. So API transaction/transactions. So instead of using this transactions, I'll be using only slash. So if someone send a request to only /transaction without anything, right? Only /transaction, then it will be handled by get transaction. So we can modify our request URL to only transaction. So if someone sends a get request to this URL, our get all transactions will be triggered. So now let's work on get transaction. Let's start by importing Mongoose. So const Mongoose, first to require Mongoose, right? And we'll be working on the transaction model. So const transaction model equals to Mongoose dot model and then transactions, right? Let's save this. In the next line, we'll be creating a variable of get transaction, or let's simply write transactions only, right? And then it will be await. So need to use async here, and await transaction model dot find, and this time we will not be running find one because we are trying to get all the data inside of the transaction model, but we need to send a condition. We need to write a condition that this transaction will be only showing the transaction to the user that is logged in, because transaction is created by a specific user, right? So we'll be writing user underscore ID, and it will be on our use request.user._id from our JWT authentication or auth middleware, right? So let's send this over to our data. So data will be the transactions, right? And let's modify this transaction to success. Let's save this and let's try to send a request. Now if I send a request over here, you can see that I am getting all the transaction related to a specific user. You can see that in user ID there is an ID called FOFOAC at the last, and this all transaction belong to a single user because we are providing a condition in which we are writing user ID must belong to the one that has logged in, right? Now by using this get transactions endpoint, we will be able to view all the transactions related to a specific user or the user that has logged in, right? But what if I only want to see the income, or what if I only want to see the expense over here? So this can be achieved by creating two other routes, get income and get expenses. So we will have total of 3 routes that will query the transaction model, but it is not an ideal way for getting the data. Instead, we will be asking the server to filter out the data and provide a response to us. So if I want to see only the expense or the income, I should be able to query a server and ask the server to provide me with the relevant data. So we can use query string parameter for communicating with an API endpoint. The query string parameter can be used by the client to communicate with the server and to provide additional information in its request. And this is how we can use it. If I want only the income to be displayed, then I can ask the server by providing the additional information that I am trying to see only the income. So I can write question mark and transaction type equals to income. And by doing this, I am sending additional information to the API endpoint using query string parameter. And we do not need to create an additional route for this query string parameter. This API/transaction that you see over here are called the path parameters. These needs to be declared in the routes, right? These are the resource allocator, but these are called the query string parameter, and these are used to only send additional data to the server or to communicate with an API endpoint. And in this way, a client can communicate with an API endpoint to send the specific data. Now let's send the request, and the response has not changed. Our client is trying to communicate with the API endpoint, but we have not written a logic in API endpoint to handle the request of the client. So let's go ahead and modify our get transaction route. So to assess the query string parameter, what you can do is you can look for request.query. For JSON payload, we are doing request.body. For parameters, we are doing request.params, and for the query string parameters, we will be looking for request.query. Now let's send this request again. And in console, you can see that we are getting an object with key transaction type equals to income, which is being sent by our client. Now we can read this and we can filter the data accordingly. So you can see that we will be getting this request.query in an object type, right? So what we can do is we can simply spread this object in our pipeline. So for doing that, what we can do is 3 dots and then request.query. So if you are not familiar with this spread operator, what this spread operator does is it takes out all the contents that is inside of the object and it will populate it right here. So when we are doing this spreading this request.query, we are simply writing this. Let's copy this and let's paste it over here. So it will take out this transaction type income and then it will populate it in this manner, and this is done by the spread operator. And if you want more information about spread operator, you can always search for it. So let's try sending the request again. So transaction type equals to income and send the request. And here you can see we are only getting the data related to an income. If I send the expense, then I am only getting the expense, right? And if I do not provide anything, then I will be getting all the transactions related to this user. And you can also send multiple query string parameters in a single URL. For instance, I want transaction underscore type to be expense. Let me send this first. And also I want this amount to be 10. So I can use and amount equals to 10. And now I'll be only getting the data which transaction type is expense and the amount is 10. So in this way, using the query string parameter, a client can communicate with an API endpoint and request for the certain data to be filtered, displayed, or to be processed. And by using the query string parameter, we are querying a same API endpoint to get different responses. And this will save us a lot of time when working with larger projects. So in the next lesson, we will be keeping some of the transaction in our user dashboard as well. We are currently only displaying the profile of the user. Now we will be adding the transaction data in the response too. So I'll see you at the next lesson. So in this lesson, we will be working on user dashboard for displaying the latest 5 transactions. So let's open up our user dashboard, Command P or Control P, and then user dashboard, right? Currently, we are only sending the user data in the response. Now let's send the transactions in the response as well. So const transaction model equals to mongoose dot model and then transactions, right? Now we will be running another function. So const transactions equals to await and then transaction model dot find, and the condition will be user underscore id equals to request dot user dot underscore id. Now let's send this transaction over to the response. And here is a simple tip to save your time. If the object key and the variable of the value is the same, then you can write it in this way. You can completely remove this, and writing in this way means doing the same thing like this. And doing this will save you a lot of time. So let's remove this. We should have done this before, but better late than never, right? So now let's send a request to user dashboard to see the response. So user dashboard and send the request. And here you can see we have a transactions key, and inside of the transaction we have an array of all the transactions related to that user. Now if you have a look at this transaction response, you can see that the recent data or the recent transaction data is displayed at the end. But we want this data to be displayed in the front in an ascending order, right? So you can use the sort function in the find query as well. Previously we did select, but now we can also use the sort. So dot sort, and then you need to type the field for sorting. In our case, it will be the created date, this data that is automatically created by Mongoose, and you will be using this data to display in a descending order. And for the descending order, you should keep dash or minus at the front. If you want the data to be sorted in an ascending order, you can only write the field name, but if you want it in a descending order, then you can include this minus or dash at the front. So let's save this and let's see the response. So send the response again, and our data is sorted by created date in a descending order. And currently we are displaying all the transactions related to that user, but in our API dashboard we should be only displaying the 5 recent results, right? So we need to limit the results. So for limiting the result, what we can do is we can use dot limit and then the limit or the maximum limit of the response. So if I want to show only 2 results, then I'll be writing 2, and I'll be getting the results of recently created 2 data because it is sorted by created date and limit 2. So let me send the request again. And here you can see I have only got 2 data and in a descending order by created date field. So let's modify this limiter to 5 so that we can have at least 5 responses in this transaction. Let's send the request again. And there you have it, 5 transactions sorted in a descending order by created date field. And this completes our user dashboard. So I'll be seeing you in the next lesson where we will be adding more features on our Expense Tracker Pro. So I'll see you there. In this lesson, we'll be working on sending emails from our Node.js app. Initially, we'll be sending a welcome email when a user registers, and then we'll be working on other functionalities as well. And we'll be using Node Mailer for sending email from our Node.js app. This Node Mailer package is not only for the development and testing email, it can be used in a real-world application for sending the emails as well. So by learning to use Node Mailer, you are also getting prepared for building a real-world applications. So let's go ahead and install Node Mailer in our project. So new terminal and then npm install node mailer. Now by installing the node mailer, we are ready to send email from our Node.js app. But to send an email, you must need a domain. Without domain, you will not be able to send email. And the domain also need to be configured for sending an email. As of now, many of us might not have a domain or the mail server. So we will be using Mailtrap for testing our email. A Mailtrap is a free tool that the developers can use to test the email. It provides a simulated environment where developer can test emails without sending it to the real recipients. So let's sign up for Mailtrap and let's see how it works. So click at sign up. You can create your free account using Google or your email address. And after registering, you will be provided with your dashboard, right? And inside of this email testing, you can see the inbox, and every email that is triggered from our Node.js app, you will be able to see it over here in my inbox, right? So in this page, you will be able to see the code for integrating this mail trap in our node mailer. So you can change this integration from call to node mailer. So it is available here. So now let's copy this code and open up our register.js page. So navigate into register.js and let's import node mailer over here. So const node mailer equals to require node mailer, right? Now let's navigate into end where user has successfully registered, and here we will paste our code. Now we need to replace this username and password with our real credentials. So for that, again navigate into Mailtrap and click at show credentials. Now copy this username. We might already have a username, but paste it here just in case. And then copy your password and then paste it over here, right? Now by doing this, we have created our transporter. Transporter is like a configuration for the node mailer for sending the email. So now that we have our node mailer transport configured, let's use it for sending the email. So transport dot send mail, and inside of it will be an object that will contain the details of the email. So first key will be the to, and it will be the receiver. So receiver will be created user dot email, right? Because we are taking the email and storing it in the email variable, right? So created user dot email, and second will be the sender. And this sender field, if we are using on a production environment and if we have our own domain and mailbox, then we will be using the sender email as an authenticated sender or our own domain that exists, right? But as we are using Mailtrap or simulator, we can use anything here. Let me write info@expensetracker.com, and the next option will be the text, the body of an email. So welcome to Expense Tracker Pro. We hope you can manage your expenses easily from our platform, right? And we'll have a subject, and subject will be welcome to Expense Tracker Pro. So let's save this and make sure that this await statement is used here. Also, we made a slight mistake over here. The sender should be replaced with from. So to and from, right? And this from is the sender. So now let's create a new account from our Postman. So navigate into the user registration page, modify the payload, and then send the request. So the account has been successfully registered. Now let's see in our mail trap. So you can see that we have received an email, and this email was sent to mike@gmail.com, the one who has registered an account, and it was from info@expensetracker.com. And this email is not exactly sent to mike@gmail.com. This mail trap service will trap all the email and list it in the mail trap dashboard. So here you can see we are only receiving the plain text. If you want to send the HTML email, then you can simply create a key called HTML and place your HTML over here. Now some email provider do not render HTML, and if the email provider could not render HTML while showing the email, then they will fall back to this text. So it is generally necessary to have this text as well. So let's copy paste over here, and let's change this to H1 and these to H1 as well, and then a little bit of space, right? And now let's try creating another account. So navigating into the Postman, let's change the payload and send the request. Now this email will be sent to tommy@gmail.com, but our mail trap will trap all the email, right? So account registered successfully. Now navigate into the mail trap, and here you can see a new email, and here you can see the HTML content that we just wrote. And this is how you work with email system in Node.js. And in the next lesson, we will be working on password resetting functionality in our expense tracker pro. So I'll see you at the next lesson. So eventually our users might forget the login password, right? So we need to create a reset password functionality. And for the reset password functionality, we need to create two routes. The first route will be the forgot password route, and second one will be the reset password. In the forgot password route, we will get an email address from our client and then send the reset code over to the email. And in the reset password route, we will be resetting the actual password. So let's start working on it. So for that, let's navigate into the modules, and the reset password and forgot password are the functions of users module, right? So let's create our forgot password route inside of this users controller. So new file, forgot password.js, and here const forgot password goes to an arrow function, and then module.exports forgot password, and this will have an SS2 request and response, right? And now let's send in response status 200, and then JSON status forgot password. And as we will be using Mongoose here, so let's import Mongoose as well. So const Mongoose equals to require Mongoose. And as we will be working with users model, let's import that as well. So const users model equals to Mongoose dot model users, right? So let's save this code and navigate into user route so that we can import this forgot password. And this forgot password will be the public route because user will not be authenticated if they forget the password, right? So we'll be writing here user routes dot post. If there is a post request and the URL is forgot password, then our forgot password functionality will be triggered. So let's save this and let's create a route in the Postman. So let's duplicate this user login, and then this will be the forgot password, right? And here it will be forgot. Let's see the link. So forgot PW password only. So forgot PW password, and then let's remove the test from here because we will not be getting the SS token, right? And in the body we will be sending the email to send the reset code to, right? So in this route the user will land and they will provide their email address, and we will be sending the reset code to this email address. So let's try sending the request. So forgot password link or forgot password controller is triggered. Now in JSON payload in body we have an email, so let's access that. So in forgot password, so const email is request.body, deconstructing this, and if email is not provided, then throw email is required, right? And now we need to check if the user exists in our database. So const get user equals to await, and then users model dot find one, and then inside of it we'll be writing our condition email matches the email that is entered by the user, right? And this will be async. And then if there is no user, then we'll throw an exception. This email does not exist in the system, right? Let's save this, and in the status let's write reset code sent to email successfully. We are not sending it right now, but let's send this anyway. And let's see if I try to enter an invalid email or that doesn't exist in our database, whether it will trigger this error or not. So navigate into the Postman again, and let me write Chris222. This email does not exist in the database, and if I send it, failed, this email does not exist in the system. Now if I send Mike over here, then you can see reset code sent to email successfully. So let's write the functionality for it now. So I can navigate into forgot password, and up to here the user has provided their email address, and if the email address exists, then we need to create a reset code and we need to save that in the user's data. So for that, what you need to do is you need to navigate into this models, and inside the user model, let's create a new field, and that field will be the reset underscore code, right? And this reset code will be of type number. Currently we will be sending number, right? And then it is not required, it is only conditional, because if someone comes into this forgot password and provide their email, then only we will be setting this reset code, right? Now let's navigate into forgot password again, and now let's construct our reset code. So const reset code equals to, and this is the function for creating 5 random digits in numbers. So we are creating a reset code. Now we need to save this reset code in the users model for this email address. So what we can simply do is await, then users model dot update 1, right? And inside of it the condition will be email equals to email, and this will be the condition for finding that user. And secondly, we will be setting the reset underscore code to the reset code, right? And then we will be using run validators true. Let's save this, and then let's write our email sending code over here, right? So navigate into this register.js and copy this from transport everything and paste it over here, and don't forget to import this node mailer. So at the top of our page, const node mailer equals to require node mailer, right? And now we will be sending an email to created, no, there is no created user, so we will be sending an email to get user.email or simply email, because we are getting the email from the payload, right? So email, and then from info at the expense tracker, it's completely fine. And let's replace this text to your password reset code is, and then plus reset code that we just generated over here, right? It's here. So we are sending your password reset code is reset code, and let's send this same in our HTML as well. And the subject will be reset your password expense tracker pro, right? Let's save this, and now let's try sending the reset code into our email address. So navigate into the Postman, and then let's send the email. So we are sending an email, password reset email to mike@gmail.com. So reset email is sent successfully. Now if you have a look at this mail trap, you can see that we have got our password reset link or password reset code, and here we have our password reset code 42661, and this code should be saved in our user database as well. So let's navigate into our users model, and then let's refresh this page, and let's find mike@gmail.com. So email equals to mike@gmail.com, and then find, and there you have your reset code. Now this reset code is sent to the email address and is saved in the user database. Now we will be using this reset code to reset the password. So we will be working on this reset section in our next lesson, and I'll see you there. So in this lesson, we will be working on the reset password functionality. Once we have sent the reset code to the user's email address, we will be using this reset code to reset password and to detect that user is entering the correct reset code from their email. So for that, let's create a new route, and then reset password.js, and this will have const reset password and then module.exports to reset password, right? And this will have an access to request and response. Also we'll be needing mongoose over here, so const mongoose equals to require mongoose, right? And inside of it we'll be writing res.status 200.json and then status reset password, right? Now we'll also be needing the users model, so const users model equal to mongoose.model and then users. Now we will be needing three different things from the payload: the email address, the reset code, and then the new password. So const email, new password, and then the reset underscore code from request.body. Before writing the logic, let's import this reset password in our user route. So copy this and paste it over here, and we will only rename this to reset password, and then this will be handled by reset password, right? And the post request is the same. Now navigate into the Postman, duplicate this, and then rename it to reset password, right? And in the body we need to send the email address, the reset code, right, and then the new password, right? Let's save this and let's trigger this. So our URL will be the reset password, and let's trigger this, and you can see we are landing at this reset password. So now that we have email address, we will be able to search for that user. So in reset password, what you need to do is we need to check some validation first. So if email is not provided, throw email is required. If new password is not provided, please provide password or new password, right? And reset code, sorry. If there is no reset code, throw reset code is required, right? And if new password dot length is less than 5, then throw password must be at least 5 characters long, right? And now let's check if this email address and the reset code that they provided exists. So const get user with reset code. So await users model dot find one, and this time we will be using two variables for finding. The first one will be the email, and that will be the variable from our request.body, and second will be the reset code that we derive from payload, right? And as this is await, this will be an async function, right? Let's save this, and if we could not find this, then simply we will return or we will throw an exception: reset code does not match, right? Now we don't need to check the user first and then the reset code, right? Because it will not be necessary, as we are checking the email address and reset code at once. Now if this does not match, if the email address and reset code does not match, then we will throw an exception. But if it matches, what we want to do is await and then users model dot update one and in condition we will be writing email is the email, because if it is correct then this email address is valid, right? And in the second parameter we will be writing password is the new password, but we will be encrypting that. So const, let's import bcrypt, but instead of that let's go into this register and bring back all the code of encrypting. So copy this hashed password and then go into the reset password, paste it over here, import this bcrypt. So const bcrypt equals to require bcrypt, right? And then we will be saving this hashed password in the password, and don't ever forget to use run validators true. Save this, and if everything goes right over here then we'll be writing password is changed or resetted, password resetted successfully, if that is the word, resetted. So let's save this, and this will be the message, not the status, and status will be success, right? Now let's try to execute this request from our Postman. So here the email address is, let's head back into this Mongoose and find mike@gmail.com. So Mike was trying to reset an password, so the email will be mike@gmail.com. So in the Postman, email address is mike@gmail.com, and the reset code is 42661, and the new password will be 12345550, right? Let's save this, but first let's try entering the incorrect reset code. So send the request, and you can see reset code does not match. But if I send the correct code, you can see password is not defined. So we made a little mistake in our code. So in this hashing we are providing password, but the variables will be new password. So let's send it over here, let's save it, and then let's send the request over again. So send the request, and then the password has been resetted successfully. Now let's head back to this user login, and let's try to log in Mike with the old password 12356. Let's try to log in, and the email and password do not match. But if I try 12345 and then send the request, and the user is logged in successfully. Now after the user has reset the password, we should be removing this reset password, because if we set this reset password or do not remove the reset password, then the user can reset the password over and over again. Like if I type 11111 and if I send, then I can reset the password using the same reset code every time. So let's remove this reset code from the database. So we will be updating multiple things. So password will be hashed password, and the reset code will be an empty string. So now let's save this, and let's try to reset the password once again. So let's use the reset code for now and send the request. And there you have it, our password is resetted successfully, right? Now again navigate into this and click at find, and you can see the reset code is null. Now the user will not be able to send the same request with the same reset code and password reset again. They need to request for a new password. So they need to go to the forgot password, send a new reset code, and once the reset code is sent, they will be receiving that reset code in the email address. So new reset code is 14822. If you refresh it, here is 14822, and using this reset code user can reset the email again. And this is how forgot and reset password works, right? Now it is generally a good approach to send a notification to the email address if the password is reset, right? So we will be sending an email notifying them that the password has been reset. And now let's send the email. Now for sending the email, you should be again copying this code and then pasting over there, but we are repeating this code over and over again. So we need to create a new file and then refactor this, and for that we will be using the email manager. and we'll centralize our email sending logic so that we still keep on following the philosophy DRY, do not repeat yourself. So I'll see you at the next lesson where we will refactor the email sending logic in one page. We'll create a manager for that, like the JWT manager, and then we'll be sending the notification email when user resets the password. So I'll see you at the next lesson. In this lesson, we'll be refactoring our email sending logic and centralizing it in one place like a JWT manager. We are doing this because we are repeating our code, email sending code over and over again. So let's create a new file inside of the manager. So we'll be naming this email manager. So email manager.js, and inside of it const email manager, right? And it will be an arrow function, and then module.exports, and then the email manager, right? Let's save this. Now let's go into this register.js and copy all of this code and then paste it in the email manager, inside of the email manager, right? And as we are using this await function statement, this function should be async, right? And the dynamic things that we need in this function is toString. So instead of using to from here, let's write to and use to over here. And another is from, and this from string will always be the same in most of the cases. If not, you can provide this from here. And then this text is always dynamic, and then HTML is always dynamic as well, and this subject is dynamic. So let's remove all of this. So from is as it is, and the text will be text, and the HTML will be HTML, and then the subject will become subject, right? It will all take the values from the function itself. Now let's save this. You have missed a comma here. Now let's save this and let's use this email manager in register. So right below this, what you will be doing is, as this is an async function, right? As this email manager is async, we'll be needing an await statement. So await, then email manager, and then inside of this email manager, we'll be having to. So our to is created user.email, right? And our from is inside of this, so we do not need to pass this from, and the text will be this, right? And then the HTML will be this one, right? And then the subject will be welcome to Expense Tracker Pro. Now let's paste this. Now you can remove all of these code from here. And also you can remove this node mailer and JSON web token from here that are not used, right? So now let's save this code. So we will be doing the same with the reset password as well. So in forgot password, where we are sending the email. So instead of this, we will be writing await, then email manager, and inside of it will be the to. So to will be the email, right? And then the text, this will be our text, and this will be our HTML, right? And our subject will be reset your password. Now you can remove all of this as well, and also remove this node mailer require. So let's save this. Now we are controlling our email sending logic from one page, email manager. And if you ever go into the production of this Node.js app, then you can use the production details here, and you are ready to send email if you are using it from many pages. So it is always a good approach to centralize your logic using a manager if you are repeating it in many different places, right? So let's test this and see if everything is working fine. So navigate into the Postman and let's send the forgot password again. So send this request mike@gmail.com, and email manager is not defined, so we have not imported this email manager. So let's go into this forgot password and import this. So at the end, ctrl space and email manager, make sure you are importing this, and also have a look at this register. Let's import this email manager as well, and let's save this and let's send the request over again. So once the server is started, send the request, and we are sending this email reset request to mike@gmail.com. So node mailer is not defined, another mistake. So another mistake is we have not defined node mailer inside of this email manager. That's a silly mistake now. So const node mailer equals to require node mailer. Right? Let's save this. And now we can finally send the forget password email. So in the Postman, and then send the request, and the reset code is sent successfully. Let's see in our mail trap. So here is the reset password. So the reset password code is 13397. So have a look. 13397, right? So let's use this 13397. Copy it and then go to this reset password and then paste it over here, and our new password will be 55555. But before sending the request, we'll be writing an email on this part reset password as well. So await and then email manager, right? Then inside of it, the first will be the to. So we'll be sending the email to email, right? And then the text will be your password is resetted successfully. If you have not done that, please contact us, right? And the HTML will be the same, right? And then the subject will be password reset successfully. Let's save this and let's try to reset our password. So again in the Postman, and then let's send the request. So the password resetted successfully, and let's navigate into mail trap, and you can see we have received a notification email that says your password is resetted successfully and you have not done that, please contact us. And it is a good approach to send the notification email when user resets the password. So this completes our reset password logic. Now it's time for us to deploy our Node.js app in the server, in the live server actually. But before that, we need to add some security measures, or we need to add some of the things or some of the packages for deploying it live. So in the next lesson, we will be looking into these steps. So I'll see you at the next lesson. In this lesson, we'll be working on delete transaction functionality. When user enters income or expenses by mistake, they need to be able to delete it, right? So we'll be working on delete transaction functionality for now. And then in the next lesson, we'll be working on edit transaction functionality as well. So let's get started by creating a delete transaction functionality, and it will be inside the transactions module. So expand this module, transactions controller, and then let's create a new file. So delete transaction.js, and inside of it, let's create a new function. So const delete transaction equals to an arrow function. So module exports delete transaction, right? So we'll be needing Mongoose here. So const Mongoose equals to require Mongoose. And then we'll be working on transaction model. So const transaction model equals to mongoose.model transactions, right? Now we'll be having an SS2 request and response. So here response.status 200.json and status deleted successfully, right? Now let's link this delete transaction to our transaction route. So if someone sends a request to transaction routes delete method, so in delete we'll be receiving transaction ID from user. So inside of it slash and then colon and then transaction ID, because it will be a dynamic ID, right? And this route will be handled by delete transaction. Now let's save this. And now let's create a route in our Postman for deleting the transaction. So inside of this transaction module, let's duplicate this, add expense, and then rename it to delete transaction, right? And it will be of delete method and API/transaction and then the transaction ID. So let me write ID for now, and in delete method we do not have body, right? Body is not accepted in delete method, but we will be sending the authorization, otherwise we will be getting an error. So let's try sending this request. So we might not have started the server, so npm start, and after the server is started, let's send the request again. So here we have the response deleted successfully. Now let's write some logic in delete transaction. So the user will be providing the transaction ID in the params, right? So let's destructure the params. So const transaction underscore ID will be available from request.params. Now once we have got the transaction ID from user, let's check this transaction ID. So const get transaction equals to await transaction model dot find one, and inside of it the condition, so underscore ID equals to transaction underscore ID, right? And as this is an await statement, this will be async. And if there is no transaction, if our Mongoose query does not return any transaction, then we will be throwing an exception, transaction not found. So now let's try sending in the request again in our Postman. So send the request, and here you can see a new error that said cast to object ID failed for value ID, and this error is occurring because we are not providing the valid Mongoose ID over here. The Mongoose ID is generally this object ID, and it should be formatted, or it should start with 648 and something like that, right? But we are only sending this ID, so this error is triggered. We'll talk about it later, and we'll also providing a fix for it. But for now, let's provide a valid ID to our delete route. So navigate into the user dashboard and send a request for getting a transaction ID. So inside of the transaction, we have a transaction in the Mike account, right? If you do not have any transaction, you can go ahead and add an income or an expense. So now that we have a valid ID of transaction, let's copy it and then paste it in our ID. So let's paste it over here and let's send the request. Now it says deleted successfully. So you can see that if you provide a valid Mongoose ID that looks like a Mongoose object ID, then we will not get any error. But if we try to replace with a simple string, anything like this, then it shows a cast to object ID failed, because Mongoose is expecting the object ID and we are sending a general string. If you look into our code, we are trying to compare this ID with the transaction ID, but for now, as we are sending this transaction ID, it is a string and it is not formatted as the Mongoose object, right? So we are getting this cast to object ID failed. So we need to check that the transaction ID that we will be getting from the user is a valid Mongoose ID, and we can use validator package for validating it. So const validator equal to require validator. So for getting the function of this validator for checking a Mongo ID, we can navigate into the validator npm package, and in the documentation you can see that we have a checking function that is called is Mongo ID. So let's copy this and then we'll be using it over here. So if validator dot and then is Mongo ID, and inside of it will always be an string, so transaction ID dot to string, right? And if it is not the case, so if this is not a valid Mongo ID, then we'll throw an exception called please provide a valid ID, right? Let's save this and let's try sending the request over again. So send the request again with an invalid Mongo ID. So if we send it, and here you can see we are getting the exception of please provide a valid ID. Now if I provide a valid ID and send the request, it says that it is deleted successfully. So our validator package is validating the Mongo ID. So now let's continue with the delete functionality. So await and then transaction model dot delete one, and the condition for deleting will be the underscore ID is the transaction ID, right, that we are getting from this payload. So let's save this and let's try to execute this in our Postman. So send the request for this transaction ID. We are trying to delete this transaction ID. So send the request, and then you can see transaction ID is deleted successfully. Now if you navigate into this user dashboard and you send the request again, you can see that the transaction is removed. But there is an issue. The transaction is removed but the balance has not updated. And it is because we are not writing the logic of updating the user account when the transaction is deleted. So let's do that. Now when deleting a transaction can be of type income or the expense, right? If the transaction type income was deleted, then we need to deduct the balance of the user. And if the expenses was deleted, then we need to add a balance to the user, and that's how it works, right? So we need to detect what the transaction type was. So for testing that, let's comment this transaction delete for once. And once we are done with the updating of user data, we will be uncommenting this. So let's see what we are getting from get transaction. So console.log and then get transaction, right? Now let's send the request again. We have already deleted that previous transaction, so let's create a new one. Let's add an income. So 10 received from friend. So add this, and then we'll also be adding an expense for testing. So 10 for movie ticket. Let's make this 5, right? And send the request again. Now inside of this user dashboard, we'll be having two transactions. One is of expense type and one is of income type. So let's work with this income first. So let's copy this transaction ID and then paste it in delete transaction. For now, our transaction will not be deleted. We are just logging the transaction object. So it's saying deleted successfully, but as we have commented, it will not work. And here we have the transaction ID that we got from the ID of user, right? Now you can see that this transaction is of type income. So what we need to do is, if user tries to delete the income type of transaction, we need to deduct the amount from the balance, right? So for that, what we can do is, if get transaction dot, and then in object we will be having this transaction type. So if get transaction dot transaction type equals to income, then we will be writing our income logic here, and if not, we will be writing our expense logic here. Now if there were more than two expense type, then we need to write LCP statement, but as there are only income and expense type, we will be doing just fine with this if else statement. So now that we will be working with the user model, make sure you are importing this users model over here. And now what can be done is, if the transaction type is income, then users model that update one, and the condition will be the user ID will be inside of this underscore ID, and then user ID will be the user ID that we got from here. So get transaction dot user underscore ID, right? And by that we will be detecting the user that had this transaction, and we will make a changes to INC, and then inside of it balance, and the balance will be the amount of transaction. So get transaction dot, and the amount is stored in this amount, so get transaction dot amount. Now as we need to deduct the amount, we will be multiplying it with -1. So let's save this, and when you are using this update one, it is mandatory that you have this validators, run validators true, right? Let's save this now. So let's copy this and then paste it inside of the expense too. But in expense, the only change is that we will be increasing the amount. If the user tries to delete the expense, then we will be increasing the amount, right? So again, save this and then uncomment this, right? Now save this again. Now let's try to delete the transaction of the user. So let's navigate into the Postman and navigate into this user dashboard. And now we will be deleting this income type of transaction. And when I delete this income type of transaction, this will be removed and the balance will be updated to 5005, right? So let's copy this and then paste it in our delete transaction, and let's send the request. So deleted successfully. Again, navigate into user dashboard for checking and then send, and then the balance has been updated to 5005 and there is no income to be seen. So now let's try to delete this expense as well. So if I delete the expense, then the amounts will be 5010, right? So again, paste this in our delete transaction and then send the code, send the request. So deleted successfully, and then again check the user dashboard. So 5010, and there are no transactions over here. Now if I try to run this delete transaction request again with the ID that is already deleted, then if I send the request, You can see that transaction not found because it is already deleted, right? So everything seems to be working fine, and we have successfully created a delete transaction route. And in the next lesson, we will be working on edit transaction. So I'll see you at the next lesson. In this lesson, we will be working on edit transaction functionality of our Expense Tracker Pro. If a user makes a mistake while entering a transaction, then deleting that transaction and creating a new one is a bit of a hassle, right? So instead of deleting and creating new one, we'll provide user with the option to edit the transaction. So let's go ahead and work on that functionality. So inside of modules, transactions, controllers, let's create a new file. We'll be naming it to edit transaction.js. Inside of it, an arrow function, module.exports equals to edit transaction, right? Now this will have an access to request and response, and then response.status 200.json, and inside of it data status edit transaction, right? Now let's import this edit transaction into our transaction routes. So let's duplicate this, and editing a transaction will be a patch request. So in this patch request, instead of getting this transaction ID through params, we will be getting this transaction ID through request.body payload. So remove this. And then if someone sends a request to transactions, and then if it is a patch request, then our edit transaction will handle the request. So now let's go ahead in Postman and then keep this route. So navigate into the Postman. Let's duplicate this one and then rename it to edit transaction, right? And it will be a patch request, and then there will be no ID params. So let's save this and let's try to send the request. So our edit transaction route is working fine. So let's start writing some codes. So we'll be needing Mongoose over here. So const Mongoose equals to require Mongoose, right? And then we'll be working on transaction model. So const transaction model equals to Mongoose dot model, and then transaction model transactions, right? And then we will be getting the transaction ID from request.body payload. So const destructuring it transaction underscore ID, right, from request.body. And if there is no transaction ID, then throw an exception. Transaction ID is required, right? Now this transaction ID will be an object ID. So navigate into the delete transaction and copy this validation logic. So copy this and paste it over here. Validator is Mongo ID, and this transaction ID is the transaction ID that we'll be getting from request.body. And if it is not a valid ID, then we'll be throwing an exception of please provide a valid ID. And then again copy this code as well. So this get transaction and paste it over here. So we will be trying to find this transaction, and as this is an await statement, this will be async, right? We will be trying to find this transaction, and if this transaction does not exist, then we will throw an exception transaction not found. Let's save this and let's try to send the request again. So navigate into Postman and body, we will be sending empty JSON. If we send empty JSON, then it will be displaying transaction ID is required. So let's type our transaction ID. So transaction underscore ID equals to, if I provide invalid Mongo ID and send the request, then it will say validator is not defined. So we forgot to import the validator, my bad. So const validator equals to require validator, right? Let's save this again. Let's send the request. So please provide a valid ID. Okay, now let's navigate into this user dashboard and get one transaction. So we do not have any transaction. Let's add income. 10 received from friend, that's fine. So again to the user dashboard, get the transaction ID, copy this ID in our patch method, and then paste it over here. Now if I send the request, you can see that edit transaction route has been triggered, and then we are getting in success status. So let's continue with our code. Now let's have a look at the transaction model and then see which fields will be allowing our user to edit. So we will not allow an user to edit this user ID because user ID belongs to that user and they cannot change to another user. So the field that we allow them will be amount, transaction type, and remarks. So in edit transaction, we will be destructuring remarks, amount, and then transaction type. Right? Now let's save this. So now let's write the update functionality. So await transaction model dot update one, and inside of it the condition will be the same that we used before. This ID belongs to a transaction ID, right? And the second parameter will be an object for making the changes. So we are allowing remarks, amount, and transaction type. So remarks will be the remarks. But for saving time, if our variable name and the key is same, then we can only write this. So remarks, transaction underscore type, and then the amount, right? Now let's save this and let's try to make a changes to the transaction. So navigate into the Postman, and this is the transaction that we will be editing. So the transaction ID is our transaction ID of income that we are getting from this user dashboard, right? This one. And let's try to make a changes to this amount. So let's change amount to 200, right? Let's save this and let's change the request. And the transaction has been updated successfully. Let's see if the changes has been reflected. So you can see that amount has been updated to 200. So let's try modifying this remarks as well. So here we'll be adding the remarks as well. And instead of receive from friend, receive from there for now. Let's send the request. And our remarks and amounts will be updated. And here you can see receive from there, and then amount has been changed. Also we can update this transaction type. So copy this and let's try changing transaction type as well to expense, right? Let's save this and let's send the request. And here the transaction type is also changed. Now what if I try to update this transaction type to something that is not in our enum? So let me write this, let me remove this expense and write some random string over here, and then let's send the request. So it's currently saying transaction updated successfully, and if I navigate into user dashboard and send the request again, you can see that we have an invalid transaction type. And this is a huge problem because this might break our entire system, right? And this is possible because we have not run validators true over here. So it is very important that we always run our validators. So run validators true. And now let's send the request again. So in edit transaction, I'll be providing invalid ID type, transaction type. And then the validation has been failed. Transaction type is not a valid enum value for path transaction type. Now instead of showing this, you can also provide your custom validation error. So for that, let's check the transaction type. So if transaction type equals to income or transaction type equals to expense, let's not write equals to. If this does not equals to income and also it does not equal to expense, then we'll be throwing an error, our custom error, transaction type must be income or expense, right? Let's save this. Now if I send the request again, we'll be getting the custom error message here, right? Now there are a lot of things that needs to be done in our edit transaction. For instance, if the user is trying to update an income to an expense, then what we need to do is first we need to deduct the income and then add the expense in the user balance, right? And if they are trying to update the amount, then we must find the discrepancies of amount and then make a change according to it in the user balance, right? So what we need to do is we need to first figure out the transaction type like we did in the delete, and then we should make the necessary changes in the user balance. So there is lot to be done in this edit transaction part if we allow user to change transaction type and amount. So we will only be allowing the users to make and changes to these remarks and not on transaction type and amount, because we need to proceed further in this course, and writing this all of this logic will extend our course time. So I leave this to you. You can detect the transaction type and you can make the necessary changes. Try for yourself. But for now, I'll be deleting this transaction type and amount, and I'll only be allowing user to make a changes to the remarks. So let's remove this as well, and then this check as well. Right? Now by doing this, we are only allowing these remarks to be updated. Now if you want the user to make an edit to transaction type and amount, then you can go ahead and write all this code. But now that you have an idea of how editing and different type of other stuff work, it is not completely necessary for you to write all the logic, and I recommend that you move further in this course where we will be working on deploying our Node.js app into the live server. So I'll see you at the next lesson. So now that we have completed all the features of Expense Tracker Pro, it's time for us to deploy our Node.js app into the live server. But before that, we need to make some changes to our code so that it can go into the production environment. Now the first thing that we want to do is to create a 404 not found page. Now if you navigate into the Postman and send a request to the URL that is not defined by our route, let's send a request, then you will be seeing an error by Express. But instead of showing an Express error, we'll be sending our own error message. For that, navigate into app.js. So right above this error handler, we will be providing our fallback route. So for that, app.all and asterisk, meaning that any requests that are not handled by this route will fall back to this app.all. And the next parameter will be handling the request. It will be an arrow function, right? And this will have an SS2 request, response, and then next function. And inside of it, we'll be writing our own 404 page. So response.status 404 for not found, and then JSON, and inside of it status will be failed, right? And then the message will be not found. Now let's save this, and now let's try to send a request again into the invalid URL or invalid route. So if I send the request, you can see I have got a 404 not found response with our own custom JSON. And if I provide the correct URL, then it will work as usual, right? And this is how you send custom 404 error response. Now next thing at our checklist before sending it for the production is to install CORS package or CORS package. And this is the package that we will be installing. CORS meaning cross origin resource sharing. Now if you deploy your Node.js app without using this package, then your front end, if you ever try to build a front end for this backend, then it will not be able to assess the resource of your backend, because resource sharing is by default only allowed on the same IP. But front end and backend may have different IPs, right? And different places that they will be deployed. So for assessing the cross resources, we will be needing this package. So let's go ahead and install this package. So close the server and then npm install CORS or CORS. Once it is installed, navigate into the app.js and right below this express const CORS equals to require CORS. And now we will be using this CORS package. So right after this express app.use and then inside of it CORS function, right? And by doing this, we are allowing our backend or API endpoint to be accessed from anywhere, right? So now that everything is set up for the live deployment, I'll see you at the next lesson where we will be pushing this code in GitHub. So I'll see you there. So now that we have completed all the functionalities of Expense Tracker Pro, it's time for us to push our code in GitHub. If you do not have a GitHub account, go ahead and create one. After you have created an account, create a new repository, right? And the repository name I'll be writing expense_tracker_pro. You can write anything that you want, and you can leave this description empty. And let's create a private repository for now, and do not check any of this and create repository. And just like that, your new repository is created. Now let's push our code in this repository. So navigate into our project, and before pushing our code to GitHub, let's create a git ignore file. So new file, and the file name will be .gitignore. And in this file we can write what files or folders need to be excluded when we push our code into the GitHub. So the things that needs to be excluded is node_modules folder, because this will automatically come when someone performs npm install, right? And another thing is .env file. We will not be pushing our .env file, as this will contain the sensitive information. So once this is done, navigate into the terminal. Don't forget to save this code and type git init. We'll be initializing the GitHub or Git repository over here. So you can see that node modules and env file will be ignored. It will not be pushed in our repository. So the next thing that you want to do is git add and dot, meaning that we want to add every other thing into our GitHub, right? And then we need to commit this. So git commit -m and first commit, and this will be our commit message, and we are committing our files to be pushed into the GitHub. Now we need to add an origin. We need to initialize our Git repository from the GitHub over here. But before that, let's create a new branch. So git branch -m and main. We'll be creating a new branch, and then navigate into your repository, this part, and copy this code and paste it in your terminal and click enter. This will initialize our GitHub repository into our project, meaning it will link our GitHub repository to our project. And now finally git push origin main. This will push all of our code into our repository main branch. Now once the code has been pushed into the GitHub, this is what it should look like, right? And now we are ready for the deployment of our Node.js app. So I'll see you at the next lesson. Now let's deploy our Node.js app into the live server, and we have selected render.com for it. Render.com provides a free hosting for Node.js app with generous limits. So let's go ahead and create a free account. So you can use any of these ways to create your account. So once you have created an account and verified your email address, this is what your dashboard should look like. Now click at new and then the web service, and it will be asking you to connect a repository. So we have our repository in GitHub, so let's connect our GitHub account. So click at connect, and then we'll be connecting our GitHub account. So authorize the render for allowing an access to your GitHub account. Now in this step, if linking of GitHub to render fails, then you want to log out your account and try this process again. Once you have got this screen, allow access to all repositories and then install. Now once you have a repository listed here, click at connect. Now you need to fill this up. So this is the name for our Node.js service. So expense tracker _ Node.js. I'll be writing this, but you can write anything over here, and you can select any region, and the branch will be the main branch, right? And the root directory, we do not want this root directory for now. And in the runtime, our Node.js, it has already selected Node.js, so it's fine. And in this build command, we will be replacing this yarn with yarn space install space and -- ignore engines, right? This render has something to do with npm, so if you write npm over here, it will not run. So you can copy this code, you can type this code over here for the build command, and the start command will be yarn run start, right? Yarn install ignore engines, and then yarn run start, and you want to choose this free instance type, right? And now we need to set the environment variable. So click at advanced, and then in advanced click at add secret file, and our file name will be .env file, right? And you need to paste your contents of .env over here. So copy the contents of your project env file and paste it over here and click at save. Now everything else will be as it is, and then create web service. Now wait for the render to create your free web service. You will be able to see the log over here, and if everything is fine, then your service will be live. Now if you encounter any error over here, you can copy those error and search for those issues in Google or get help from ChatGPT. And if everything is okay, then your server will be live. Now to confirm that your server is live, scroll at the top, and here will be the URL for your API endpoint. So click it here, and then you should be able to see the not found page. So if you are seeing this JSON that you wrote, then your server is live and ready to be tested. So again, if you want to see your URL when you log in next time, you can click at dashboard and then this web service, and here will be the URL for your API, right? Now in the next lesson, we will be testing our live URL to see everything is working fine. So I'll see you at the next lesson. Now in this lesson, we will be testing our live deployment to see if everything is working fine. So once you have got your URL for API endpoints, copy this URL, and now let's navigate into the Postman to check our live URL. So open up your Postman, and in environments, go into this ETP environment, and you want to replace this URL with the new URL. So paste it, and our API endpoint will be /API, right? So copy this and paste it over here as well. So save this, and your current value should look the URL address and then /API. Now go into your collection and try using the user login. Now before sending the request, let's replace this localhost 8000 with our environment variable URL. So remove this and also remove this API because it is also in our environment variable URL. So use URL over here with 2 curly braces and then /user/login. So try sending the request. And here you can see you have got the response from live server. So congratulations, you have successfully deployed your Node.js app in live environment. Now let's go ahead and test other API endpoints as well. So let's go into the user dashboard and also replace this localhost 8000/API with the URL in environment variable. So replace this with URL, right, and send the request. And here you have response from the live server. So now go ahead and replace all of this localhost 8000 with environment variables URL, and you will be able to test all of the API endpoints. So this completes our Node.js course, and I hope that you have learned a lot from it. I can't wait to see what you build with this. And a huge congratulations for completing this course.